Hello everybody, hello everybody, hello, 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 how are you all? Let me get my mic. Actually, somebody called and I had to take up the call. Hi, all of you. All good? Having fun? Hi, Srikar. Hello, Siddharth. Hello, Rukmini. New to this channel. Welcome, Siddharth. Welcome. Not a very old channel. The channel itself is very new. So we are doing matrices and determinants now. Okay, we did binomial theorem. We even had a practice session on binomial theorem. Similarly, we are going to have a practice session on matrices and determinants also, but let's first firmly, accurately cover up each and everything with questions of matrices and determinants. It's a big chapter, okay? It's a long chapter. Many people think it's an easy thing. We'll do it in the end, or we'll keep it for the end. We'll revise later, or it's a small chapter, can be completed in one day. It's not like that. You need practice for this chapter. Both of the things, matrices as well as the determinants, both are connected. If question comes, it will involve matrices as well as determinants. So today we are going to see all the concepts, all the things that we need to know in this session. Completes whole chapter. Yes, we will complete the entire chapter, beta. We will definitely complete the entire chapter. If not determinants, then at least matrices part I'll try to complete in the one shot only. Okay, determinants will keep one more shot if required. Most probably I'll try that if we can cover up both of the things. So chapter is designed in such a way that you get a knowledge of both matrices and determinants, and this is going to prepare you. Sir, will next session be tougher than the before one? Yes, generally according to the previous trends, the second attempt is supposed to be a bit more tougher than the first attempt, but again shift it will depend. So it's not 100% sure, it's just likely. The certainty says that yeah, the second attempt is supposed to be a little more tougher than the first attempt. That's there. Now let's come on to the topic of the day, which is our matrices and determinants. Very important thing, very important topic. In mains itself, if you see, if this attempt, each of the shift had at least one question of matrices. Determinants specifically, they cannot ask you anything, but yeah, combining determinants with matrices, a good question can be formed. So first, let's understand everything that we require to know for matrices up to mains and advanced level, all done and dusted in just one session. Let's start First of all, what is a matrix? Matrix has a value. How many of you think that matrix has a value? Matrix does not have a value. Determinant of a matrix has a value. Matrix is just a box like this in which elements are there in rows and columns. Right? It's just a box like this in which elements will be there in rows and columns. Something like this. A11 means element of first row, first column. A12 means element of first row, second column. A13 means element of first row, third column. Right, element in first row and third column. Similarly, A1n means element in first row and nth column. Right, so it's not necessary that a matrix is always going to have something like this: 1 2 3 2 3 1 1 3 2. Right, it is a square matrix which is well known to you, which you all know about. Right, this looks like a square matrix, but matrix can have any number of rows and any number of columns. A matrix is this box. This does not have a value. Determinant of matrix has a value. This should be very, very clear. Matrix has to be solved just like a matrix only. So very important rules are there, very important concepts are there which we need to be thorough, which we need to be sure about for solving the questions based on matrix. Now matrix can be of any type. One column, 1 2 3, this is also a matrix. Only one element, first row, first column, this is also a matrix. In this type of boxes you have to enclose. Now only one column, 1 2 3, this is also a matrix. Two rows and three columns, 3 rows and 2 columns, 1 2 3 4 5 6. Now what is this? 3 rows are there, 1 row, 2 row, 3 row, and 6 elements are there. 3 rows and 2 columns are there. So 3 into 2, 6 elements. 3 rows and 2 columns. Row into column is the way of writing the order of matrix. For example, this matrix, 1 row and 3 columns. So 1 into 3 is the way of defining the order of this matrix. What is this matrix? 1 2 3 rows and 1 column. So 3 cross 1 is the order of this matrix. Row into column. How many rows? How many columns? 1 row, 1 column. So 1 cross 1 is a matrix, is the order of this matrix. That's it. That's how you write a matrix. That's how you describe a matrix. Now there are some types of matrix based on which question can be asked directly. Right, these types, these names can be involved in your question. Let's quickly understand what do we mean by a row matrix and a column matrix. Row matrix means only row is there, there is no column. Right, there is no column, like only one row is there. Right, columns obviously will be there. Without row and column, both will be there, but only in one row if we define a matrix, that is your row matrix. That means if I define something like this, 1 2 3 4 5 6 and so on, only one row is there. Order means 1 into 6. Columns are 6, but only one row is there. So only one row, that means row matrix. Similarly, only one column, that means a column matrix. As simple as that. So only one column means, one column means something like this, 1 2 3 4. So this will be, how many rows are there? 1 2 3 4. 4 rows are there, but column is 1. So only one column. Number of columns should be 1. Here number of rows should be 1. If number of rows is 1, then it's a row matrix. If number of columns is 1, then it's a column matrix. Now zero or null matrix. Zero or null matrix means all the elements. Look over here, we are defining the elements as A, I, J, where I represents row and J represents column. Right, this is how we are defining. So if I'm saying A32, that means third row and second column. That's it. A32 means third row and second column. The element at third row and second column will be A32. So Aij defines the position of an element in a matrix, where I represents the row and J represents the column. That's it. Now if I say for a zero matrix, Aij is equal to 0 for all I and j. If I simply say Aij is equal to 0 for all I and j, that means in this matrix all the elements are 0 0 0 for all I and j. These are 0. So that will be called as zero matrix or null matrix. Very important thing, sometimes required in the question. Very simple thing also. Horizontal matrix in which rows are more than columns. Oh, I'm sorry, it will be ulta, right? Which you remember it like this, which will look horizontal. Which will look horizontal. Now if my number of rows is more than number of columns, suppose I have 4 rows and 3 columns. So 4 rows means 1 2 3 4, let's say 5 6 7 8 9 10 11 12 13 14 15 16. Let's say this is my matrix. Now what does this look like? It looks broad or it looks tall? It looks broad. Why? Because number of rows are, sorry, columns should be 3 only. This looks like 5 6 7 9 10 11 13 14 15. Okay, let's make it like this. 4 rows and 3 columns. Now what does it look like? It looks tall or broad? It looks taller, right? Its height will be more than its breadth. So that is why it is horizontal matrix or vertical matrix. Tell me, which type of matrix would you tell it? It will be a vertical matrix. Its height is more than its breadth, right? If we compare in units, the height will be 4 units but breadth will be 3 units only, right? So when is it happening? When number of rows is more than number of columns. When your number of rows is more than number of columns, then you'll get a vertical matrix. I should write over here. Number of rows is greater than number of columns. When number of rows will be more, it will increase the height, right? So it will look like a vertical matrix. How many accepted R's in expected R's? 3 to 4 beta, 3 I think, right? Horizontal matrix means number of columns is more. Now number of rows, if they are less than number of columns, suppose I have 3 rows and 4 columns, right? 3 rows and 4 columns. So 1 2 3 4 5 1 2 3 4 columns, no? So 3 4 5 6 7 8 9 10 11 12, right? 4 columns and 3 rows. How is it looking? It is looking horizontal. Now width is more. So if width is more, that means it is a horizontal matrix. Number of rows less than number of columns. Columns are more, then it will be broader. If rows are more, it will be taller. So when rows are more than columns, then it will be a vertical matrix. When columns are more than rows, then it will be a horizontal matrix. As simple as that. If rows is equal to columns, then it will be a square matrix. 3 cross 3, 2 cross 2, 4 cross 4, all these are square matrix, right? 4 rows 4 columns, 4 rows 4 columns, 3 rows 3 columns, 2 rows 2 columns. These are all square matrix. Very simple to understand. Many properties do rely on square matrices itself. So understand this very carefully. Now special things about square matrix. In square matrix, AII will be called as diagonal elements. AII means A11, first row first column, A22, second row second column, A33, A44, A55. These will be diagonal elements, right? So for example, if this one is my A11, this is A first row second column, A first row third column, A first row A second row first column, A second row second column, A second row third column, A third row first column, A third row second column, A third row third column. Now if I talk about these are my diagonal elements, A11, A22, A33. If it was a 4 cross 4 matrix, then I'll have A44 also. Now in diagonal elements will only lie in a square matrix. When we talk about diagonal elements or when we talk about diagonal, we are specifically talking about a square matrix over there. Very important, right? We are specifically talking about a square matrix over here. Now Aij and Aji are called conjugate elements. Aij and Aji are called conjugate elements. What do you mean by that? A12 and A21. For example, if we talk about A12 and 21, these are conjugate elements. A13 and A31 are conjugate elements. right? A23 and A32, Aij and Aji are the conjugate of each other. Very important concept. Aij and Aji are the conjugate of each other in a square matrix, right? On the either side of your diagonal. A12, A21, A13, A31, A23, A32. These are your conjugate elements. Very important when we'll be, sir, this are basic little bit, just speed up. Yeah, beta, just a minute. Just let's brush up everything. Triangular matrix and diagonal matrix. If we have elements only in the diagonal, A, rest everywhere we have 0. This is your diagonal matrix, right? If you have element only in the diagonal, rest everywhere is 0. That means this is completely 0 and this is completely 0. Only in the diagonal you have elements. Sometimes, very rarely, especially in CBSE, they might ask you about triangular matrix. What is a triangular matrix? So instead of A11, A22 and A33, if we have elements over here, that means A21, this is also an element, A31, A32. Rest everything is 0, right? Rest everything is 0. In that particular case, we'll call it a lower triangular matrix. They might ask you definition wise, especially in boards, lower triangular matrix, just for definition. Now if lower element becomes 0, that means if we have A11, A12, A13 is there, A22 is there, A23 is there, and also A23 is there. Oh, sorry, A33, A23 is there. Remaining these are 0. Then it will be called as your upper triangular matrix. This will be called as upper triangular matrix. Just for information, you need to know these. This will be called as upper triangular matrix because elements are there in the upper part. So upper triangular elements are there, non-zero elements are there in the lower part. So this is the lower triangular matrix. It's important to know these for information. Okay, upper triangular, lower triangular. In upper triangular, these are not equal to 0, right? These are not. Now, one thing which is important to notice over here, if you look at the diagonal, right? A11, A22, A23. Now, the elements which are above the diagonal, that means these A12, A13, A23. In these, J is always greater than I. Look at this. J is always greater than I. 2 greater than 1, 3 greater than 1, 3 greater than 2. Now, in the lower part of diagonal, J is always less than I. In the upper part, J is greater. In the lower part, I is greater. Here, 2 is greater than 1, right? 3 is greater than 1. 3 is greater than 2. So in the upper part of the diagonal, always J will be greater. In the lower part of the diagonal, always I will be greater. Sometimes in questions, they might use terms like this, that for all I greater than J, Aij is equal to 0. So wherever I is greater than J, the elements are 0. And here, wherever J is greater than I, the terms are 0. That means lower triangular. Okay, very important, simple thing. Scalar matrix, that means only diagonal elements are there, right? Diagonal matrix or scalar matrix, same thing only. Diagonal matrix or scalar matrix, same thing only if these terms are real. That means scalar terms are over there, then it will be called as scalar matrix. And for this also, if we have something like this, then this will be a identity matrix. In identity matrix, only the diagonal elements are equal to 1, rest everything is equal to 0. This particular case will be called as the identity matrix. Let's go ahead. Any doubt till here? Anything you want to ask? Please don't forget to like the session. Now, algebra of matrices, which is the most important part, where the most of the questions will be asked from algebra. Addition, subtraction, multiplication, taking common, powers of a matrices, all these come in this part. Now, two matrices, simple thing, two matrices are said to be equal if they have same order. First of all, two matrices can only be equal if they are of same order. Very, very important thing. If two matrices are of same order, then only we can consider them to be equal to one another. Second thing, that corresponding element should be equal, right? For example, over here, if these two matrices are equal, for what value of x and y following matrices will be equal? First of all, check the order. Order is same. Yes, they can be equal. For them to be equal, corresponding element should be equal to x plus 1 should be equal to x plus 3. This gives us x is equal to 2. Correct? 2x minus x, x, 3 minus 1, 2. Directly this gives you x equal to 2. Now, your 3y is equal to y square plus 2. Right? 3y equals to y square plus 2. So this gives you y square minus 3y plus 2. Right? So minus 2 minus 1, this will be y minus 1 into y minus 2 equals 0. So y should be equal to 1 or y will be equal to 2. These two values we are getting. One more equation we have though. Then y square minus 5y should be equal to minus 6 also. 0 equal to 0, but this should also be true. So y square minus 5y plus 6 equal to 0. Minus 3 minus 2. Right? So this will give you y minus 3 multiplied with y minus 2 equals 0. So y can be equal to 3 or y can be equal to 2. Now y can be equal to only one value. We'll take the common value. Right? So which will be the common value? Simply we'll take y equal to 2 from both the sides. So according to the solution, my x should be equal to 2 and y should be equal to 2. In that case, I'll get an equivalent matrix. Both matrices will be equal in that case if I take y equal to 2 and x equal to 2. Right? If I take y equal to 1, then these will be equal, but these won't be equal. Okay, so you have to take the intersecting value, that is y equal to 2. Now let's see some more questions in this scenario only. In algebra, they can give, if they want to give you a question just for comparison, they'll give you a question like this. Now try solving this. Sir, degree 4, x to the power 4 minus 2x cube plus 3x square should be equal to 2x minus 1 if these two are equal, because order is same, 2 is equal to 2, only one term is remaining. That means this. Can we solve this very easily? Now sir, degree 4, x to the power 4 minus 2x cube plus 3x square minus 2x plus 1 equal to 0. This is what it gives me. How to solve a degree 4 polynomial or find the factors? Now, if they are giving you a degree 4 polynomial, or if they are giving you a degree 4 expression, they'll definitely make sure that you are able to take out things common. For example, if you look at the coefficient of x to the power 4 and x over here, right? If you look at the coefficient of x to the power 4 and x square, let's say, so this is 1 and 3, but x to the power 4 coefficient and x to the power 0 coefficient is same. Similarly, x cube coefficient and x coefficient is also same. Now, whenever this is the case, always, whenever you get a degree 4 polynomial or degree 4 expression, always do one thing, divide by x square and see what's happening. So if we divide by x square, what do we get? We are just dividing by x square. Let me decrease the thickness. Yeah. So when I divide by x square, what am I getting? This will become x square minus 2x plus 3 minus 2 by x plus 1 by x square. Now, what will happen? X square and 1 by x square I can club. X square plus 1 by x square I can club. Minus 2 if I take common, x plus 1 by x also I can club. Minus 2 if I take common, x plus 1 by x will also come as clubbed, and plus 3 I'll keep as it is separately. Right? Things are sorted. Now I know that x plus 1 by x whole square minus 2 if I'm doing, then that gives me x square plus 1 by x square. I know that, right? Right? This I can use. This thing I'm going to use over here. That's it. X plus 1 by x whole square minus 2 will be x square plus 1 by x whole square. So what I'll do over here, x plus 1 by x whole square minus 2 times x plus 1 by x plus 3 equals 0. Now this I'll take as t. That's it. X square, x plus 1 by x I'll take as t. What's the problem? X plus 1 by x I'll just take as t. So this will become t square minus 2t minus 3 minus 2 plus 3, that means plus 1 equal to 0. T square minus 2t plus 1 equal to 0. Minus 1 minus 1. Right? So that means I'm getting t minus 1 whole square. What is this? T minus 1 whole square only, no? t minus 1 whole square equal to 0. That means x plus 1 by x minus 1 whole square equal to 0. Correct? So what am I getting? X square plus 1 minus x equals 0. So x square minus x plus 1 equals 0. This is what I'm getting. Does that have a real root? Does that have a real root? Tell me quickly. Does that have a real root? No real root, right? X plus 1 by x will be equal to 1. That means x square plus 1 minus x is equal to 0. So that means there is no such value of x, no real x. We'll simply say no real x. That will be our answer. There is no real x for this, for which this situation will occur. As simple as that. X square take common. Yes, very good. Right, let's move ahead. If these two are equal, now here also you can put no real root. Very good, Rukmini. Very good. Just give me a minute. Okay. Now solve this. Very easily you can solve this also. Here you just need to use a plus b plus c whole square. Right? A square plus b square plus c square plus 2 times ab plus 2 times bc plus 2 times ca. That's it. These type of problems will come. This type of problem. So this is very simple, right? This equate it equal to this, subtract. You'll find the relation between PQ and R. Simply 4P square plus 16Q square plus R square minus 2 times into 2P into 4Q. Correct? This is what it is becoming, no? 4 square and 2 square. So 2P and 4Q. Correct? No, it will become 8PQ, yeah. Wait, we are doing something wrong. 2P whole square. So let's write it like this. Wait, 4P, that means 2P whole square plus 4Q whole square plus R square minus 8PQ. So 8PQ can be written as 2 times of 2P into 4Q. No, we cannot write it like that. Kya? We cannot write it like that actually. Can we write it like this or not? No. 2P 4Q. So here what we need to do, here we'll need to use one property, right? You know, right? X square plus y square plus z square minus xy minus yz minus zx. If this is equal to 0, there is one property which we learn in class 10. Can you tell me about it? If this is equal to 0, then what is the condition? If x square plus y square plus z square minus xy minus yz minus zx is equal to 0, then this simply resonates that x is equal to y is equal to z. That's it. This is something which we learn in class 10, right? A cube plus b cube plus a square, and you can prove it also. If this is the condition, then x will be equal to y will be equal to z. Okay, so in this case we are getting this particular scenario. So that means 4p that means 2p whole square plus 4q whole square plus r square minus 2p times 4q minus 4q times r minus 2p times r. This is the exact thing which will come out. If this is equal to 0, then we can simply say 2p is equal to 4q, that is equal to r. As simple as that. That was the catch over here. No real root. Yes, Rukmini, no real root in the last one. Is this clear? So these type of questions can be asked from you. Here you'll just have to use these were some tricky ones. Usually they'll be easy ones. Sometimes factorization, sometimes identities will help you in this case. Now, how to add the matrices? How to add? Add element by element. We can only add when the order is same. Two matrices of same order are added term by term. Every element will be added as it is. Multiplication, just suppose if I am multiplying 3 in this particular matrix, then I'll multiply 3 with each and every element of the matrix. Then I'll have to multiply 3 with each and every element of this matrix. Okay, very clear? Solve this. Let's see how quickly we can solve this. 3a minus 2b plus 3x is equal to 0. So we need to find the matrix x. Now we know 3a minus 2b is plus 3x is equal to 0. Now if I want to find x, these are all matrices. A, b and x all are matrix. So this will become 2b minus 3a. Correct? And x will become 2 by 3b minus a. Correct? Because 3 I am dividing. So I can divide like this. Multiplication and division can happen throughout the matrix. Now I'll just find this. I'll find 2 by 3 of b. What is b? 2 by 3 times b. That means minus 4, 3, 1 and minus 2. Minus a. What is a? 5, 3, minus 1 and 2. This is my a. So I'll just multiply 2 by 3 over here. So it will become minus 8 by 3. This will become 2. This will become 2 by 3. And this will become minus 4 by 3. I'll subtract from 5, minus 1, 3 and 2. Addition and subtraction not very. 8 minus 8 by 3 plus 5 minus 8 plus 15. So 7 by 3. So this will give me 7 by 3. Right? Subtracting simply 2 minus minus 1. So that will be 3. Now 2 by 3 minus 3. Achha, it will be minus 8 by 3 minus 5. So minus 8 minus 15. 28 it will be. 28. Here it will be 28. Minus 8 by 3 minus 5 will do. 2 minus minus 1 will do. 2 by 3 minus 3. So 2 by 3 minus 3, that means 2 minus 9 minus 7 by 3. This will become minus 7 by 3. And minus 4 by 3 minus 2. So minus 4 minus 6 minus 10 by 3. That will be our matrix x. This will be our matrix x. This is how you'll have to solve simple equation. Minus 28 by 3, 3, 7 by 3 and 10 by 3 is our final answer, which is our matrix x. Okay, this should be clear, right? If you want to solve simply, you can solve simply also. Multiply 3 over here, 2 over here, 2 in this one, and then solve this and then take it on the other side. Not a problem. But don't open the matrix. We don't have a value of matrix. Okay. Now multiplication of two matrix. Very important thing, very basic thing, very simple thing. But sometimes students get really confused. Order means, suppose if I have two matrix, first matrix is of order A into B. Second matrix is of order C into D. Can I multiply them? No, I cannot multiply them. I cannot multiply them. I can only multiply if this was B into D. That means this number and this number. Number of columns in the first matrix and number of rows in the second matrix which we are multiplying should be equal to each other. Then only we can multiply. Very basic rule of multiplication of matrix. Now what will be the order of matrix which we are going to get? That will be A multiplied with D. A multiplied with D will be the order of matrix which we are going to get. Let's clear this with simple examples, very fast, real fast. Pre-multiplier, post-multiplier. These are some terms you should know. Post-multiplier means second, the second which we are multiplying with. Pre-multiplier means these matter. Why? Because AB is not equal to BA in case of matrices. That will come. Okay, let's move ahead. Two matrices can only be multiplied if the number of columns of pre-multiplier is equal to number of rows of post-multiplier. That means post-multiplier means the second one, pre-multiplier means the first one. So here n and n are equal, then only we can multiply, and the order of the matrix that we are going to get will be M multiplied with P, M cross P. That will be the order of the matrix that we are going to get. Matrices are multiplied in rows by rows and column by column. Let's understand with the help of example. For example, these two matrices, can we multiply them? This is 2 cross 3. This is 3 cross 4. This and this are equal. The order of the matrix that we are going to get will be 2 cross 4. This should be already known. This and these are equal. That means we can multiply, and the order of matrix that we are going to get will be 2 cross 4. This easily you should be able to. Now how to multiply? Now take this matrix, right, and this one. Now why am I saying the order of a matrix which will be formed will be 2 cross 4? You can check by multiplying. Take first row and first column. 2 multiplied with 1 plus 3 multiplied with 2 plus 4 multiplied with 0. That means 2 plus 6 plus 0. That means 10. 2 multiplied with 1 plus 3 multiplied with 2 plus 4 multiplied with 0. Complete first row and complete first column, product and addition. Now, so we are going to get 2 rows and 4 columns. We'll have 2 rows and 4 columns. This was first row, first column. First row, second column. First row, second column. 2 into 0, 0. 3 into 1, 3. 4 into 1, 4. 4 plus 3, 7. First row, third column. Right? 2 into 4 will have 2 rows and 4 columns. So 1, 2, 3, 4. 4 columns. 2 into 1 plus 3 into 1 plus 4 into minus 1. 2 plus 3, 5. Minus 4, that means 1. Now, 4 plus 6 plus 12. So, 22. Now, second row. Second row, first column. 1 into 1, 1. 2 into 2, 4. 3 into 0, 0. That means 5. 1 into 0, 0. 2 into 1, 1. 3 into 1, 1. So, that means 5 again. 1 into 1, 1. 2 into 1, 1. 2 into 1, 2. That means 3. 3 into minus 1, minus 3. 3 minus 3, 0. Now, over here, 1 into 2, 2, 2 into 2, 4, 3 into 3, 9. 9 plus 4 plus 2, 15. So this will be our multiplication. That's it. This is what? This is 2 cross 4. This is why we are going to get 2 cross 4. Because first row, first column. First row, second column, first row, third column, first row, fourth column. Very basic thing, but you must know this. You must try doing this once on your own if you haven't tried this before. Alright, so 2 cross 4 will be our matrix. Can we multiply over here? Yes, 1 into 1 and 1 into 2. We can multiply because these two are same. Final matrix which we are going to get will be 1 cross 2. That means 1 row and 2 columns. That means only 2 elements. 1 row and 2 columns. That means A11 and A12 will only be there. 1 row and 2 columns. Okay. What will they be? 1, 1. First row, first column. 1 into 1, 0 into 2, 2 into 3. 6 plus 1, 7 plus 12. 12 plus 7, that means 19. Now first row, second column, 1 into 1, 1, 0, 0, 3, that means 4. 19 and 4 will be the multiplication of these two matrices. That's it. That is 1 cross 2. This matrix is of 1 cross 2. The feeling won't come until unless you try this. Sir, before question, first element is 8. 2 plus 6, 8. First element is 8. First element is 8. Correct. Yes, Rukmini. Alright. So this is basic. Try these once on your own. Now A and B are two matrices of order 2 such that A plus B is this, A minus B is this. This type of question also can come. A plus B is given to you as a matrix which is 2, 0, 3, 4. Square matrix obviously. A minus B is given to you as 0, 2, 5, minus 2. Again a square matrix. They want you to find A cube. So can you add and subtract like linear equation? Yes, you can, until unless you are not opening the matrix and following the rules. Now A is some matrix, B is some matrix. Let's say when we add both of them, we'll get 2A. B minus B will become 0, will be equal to sum of these two. So 2 plus 0, add element by element. 2 plus 0, 0. 0 plus 2, 2. 3 plus 5, 8. 4 minus 2, 2. This will be your 2 times A. So your A will become how much? This 2 will be divided, or 1 by 2 will be multiplied in 2, 2, 8, 2. So what are we going to get? A will come out to be as 1, 1, 4, 1. This will be your A. Now they want you to find A cube. Now they want you to find A cube. Mark my words, there is no direct method of finding a power like binomial coefficient or binomial problem. That's not going to work over here. You'll have to actually check and multiply. So first I'll find A square. A square will be what? Simply 1, 1, 4, 1 multiplied with 1, 1, 4, 1. Let's see what is A square coming out to be. So 2 into 2, 2 into 2. Final answer will also be 2 into 2. 1 into 1, 1 into 1 plus 1 into 4. That means 1 into 1 plus 1 into 4. 4 plus 1, 5. Now 1 into 1 here 1 into 1 plus 1 into 1, that means 2. Now 4 into 1 plus 4 into 1, that means 8. Now 4 into 1 plus 1 into 1, that means 5. Now a square is coming out to be 5285. Can you see that? Now similarly you'll have to find a cube. That is, just multiply a once more over here. Nothing major. Right, 5285 is your a square. A cube will be nothing but, multiply this, a cube will be nothing but 1141 multiplied with 5285. You have to be really good at calculation and very careful while calculating. That's the key. Okay, so 5 plus 8, that means 13. 2 plus 5, that means 7. 20 plus 8, that means 28. And 8 plus 5, that means 13. This will be your answer of a cube. Simply. Right? So this is how, just right now, just brushing up all the things so that you are in the flow, you come in the flow even if you are watching the video. Then try to do these things on your own once. AB is not equal to BA in case of matrices. It's not necessary that I'm multiplying A and B. Whatever matrix I'm getting, that same thing I'm going to get for B multiplied with A. It won't happen. Right? This won't happen in case of matrices. This will happen only in a special case, which is this. Suppose I'm taking right, these two if I'm multiplying, right, and if I multiply these two, so order matters in multiplication. Only in this case they'll be equal. What am I getting here? So 2 plus 0, that means 2, and I'm getting 3 plus 0, that means 3. Now over here 0 plus 4, that means 4, and 0 plus 5, that means 5. This will be 2, 3, 4, 5, and here also I'll be getting 2, 3, 4, 5. Why am I so sure? Because this is an identity matrix. This is your identity matrix, which is represented by I. Only in case of identity matrix, IB will be equal to BI. We can say that. Only in case of identity matrix, this will be applicable, this will be true. Otherwise, it is not true for every matrix. We cannot say AB will be equal to BA in case of matrices because they are not commutative under multiplication. Okay, you must have studied about commutative and associative property, right? So if we do A plus B whole square, and if I'm saying A and B are matrices, so it will be equal to A square plus B square plus AB plus BA. It will not be equal to 2AB. It will not be A square plus B square plus 2AB. Why? Because AB and BA are not equal. So we cannot club them and say 2AB. They are not equal. They are two different things, right? So remember that in case of matrices, we cannot apply this. AB is equal to A, BA is equal to B, find B square. AB is equal to A, BA is equal to B. We have to find B square. How can we find this? Now B square we are finding, right? B square we are finding. We know BA is equal to B. If we want to find B square, we'll have to create B square. So I'll do B. I'll multiply B on the right side, right? Which side you are multiplying in matrices, that also matters. So this one will become BAB and this will become BB, multiplying. So this will become B square for sure, right? This will be B square. What will be this? B into A into B. Now A into B is A, right? This is A. So I'll write BA, right? And BA is given to me as B. So B square will be nothing but equal to B, simply solved. Many questions do come in mains just like these, very simple ones. But because students skip this chapter, they won't be able to attempt this much also. So don't do that, right? Especially in boards, MCQ and all will ask you these type of questions, very easy, just based on rules. If A square equal to A, show that I plus A whole cube will be equal to I plus 7A. If A square is equal to A, then I plus A whole cube will be equal to I plus 7A. How will we show that? Right? I plus A whole cube we want to do. We'll just apply the identity. Na? I plus A whole cube. Identity though we can apply. Right? Whatever these are variables or matrices. But we just know AB will not be equal to BA. That's it. What is the identity? A cube, that means I cube, plus A cube, that means A cube. A cube plus B cube plus 3AB, that means 3 times of I into A multiplied with I plus A. Correct? So what will this become? This will become I cube plus A cube plus 3IA, that means 3I square A plus 3I A into A, that means 3IA square. Correct? Now they are saying I cube, that means I into I into I. If you keep multiplying the identity matrix, it won't matter, right? It will become I only. A cube, what is A square? A square is equal to A. If we multiply A on both the sides, this will become A cube, this will become A square. Correct? If A square already is given to A, then A cube will be also A. Now if A square, remember that if A square is equal to A, then all the coming powers, A cube, A4, A5, A6, A7, A to the power n will also be equal to A for all n greater than 2. Write it down. If A square is equal to A, then any power of A will be equal to A only for all greater than equal to 2. This will be surely correct. So that means A cube is also equal to A. 3I square, that means 3I into A, that means 3IA or 3A. Multiply any matrix with identity matrix, will always get the same matrix. Identity matrix, multiply with any matrix, you will get the same matrix. You have seen here, right? Just now I showed you. Where did it go? Okay, didn't come. I think I removed. Multiply identity matrix with any matrix, you'll get the same matrix. A square is equal to A already. So 3IA square will become 3IA. That means 3A. 3A plus 3A, 6A plus A, 7A. So there will be I plus 7A. Simply proved. What's written over here? I and A commute with each other. I into A will be equal to A into I. Right? Multiply any matrix with identity matrix, you will receive the same matrix as the result. Very simply proved. Okay, let's see some more questions. One question from JEE Advanced. Now, generally students solve it with a very long method. There is one method which is suggested by every good teacher, that you should use this method and you should know this method if this type of question comes. If they are asking you to find a very high power of a matrix, then how should you try, or what should be your approach towards that particular question? This is very important. Okay, now what am I going to do over here? I am going to write this matrix as a sum of identity matrix and some other matrix. Always try that. So if I want to write it as a sum of identity matrix and some other matrix, so M will be equal to identity matrix, that means this one, plus some other matrix. Now I want 1 plus something to be equal to 5 by 2. 1 plus something to be equal to 5 by 2, that means here I should have 3 by 2. Then only 1 plus 3 by 2 will be equal to 5 by 2. No? Right? 1 plus something should be equal to 3 by 2. So that will be 1 by 2. 0 plus something. So here we'll have 3 by 2 only. 0 plus something, that means here we'll have 3 by 2 only. 0 plus something, that means minus 3 by 2. 1 plus what will give me minus 1 by 2. 1 plus what will give me minus 1 by 2, minus 3 by 2, right? 1 minus 3 by 2 if I am doing, check, 1 minus 3 by 2, 2 minus 3 minus 1 by 2. So minus 1 by 2 if I want, then I'll have minus 3 by 2 over here. Beautiful matrix. All elements same, only just plus minus, right? First of all, this will always happen. Now I'm writing my, this one I'm calling as, this one I'm naming as some A, and this is my I already. Correct? So I'm going to write my M as some I plus A. And similarly, M to the power 2022 will become I plus A to the power of 2022. Now binomial expansion will be applicable here also without any worries. Correct? Till here any problem? This is how you have to write your matrix in terms of I plus some matrix, I plus A. I'm calling this matrix as some A. Okay. Now I plus A to the power of 2022. I'm going to open it. How will I open it? NC0, that means 2022 C0. I to the power 2022 and a to the power 0. That means I to the power of 2022. A to the power 0 doesn't matter, right? We don't need to write it. Now, second, 2022 C1 NC1 I to the power of 2021. I to the power 2021 and a as it is, a to the power 1, that means a as it is, right? Plus again 2022, just writing for your C2 I to the power 2020 and a square. Now further when I'll write, it will come 2022 C3 I to the power 2019 and a cube. Next will be a to the power 4, a to the power 5, likewise. Now I know that if a square is 0, then all of them will be 0. All these terms coming forward will be equal to 0. That trick I'm going to use over here. Now I'll find a square. What is a? 3 by 2, 3 by 2, minus 3 by 2, minus 3 by 2. My a is this. Right? When I'm finding a square, try finding a square. What is a square coming as? What will be a square? A square will be this multiplied with same thing. That means 3 by 2, 3 by 2, minus 3 by 2, minus 3 by 2. When these type of terms are there, no, we can directly say it's going to be 0. Check. This into this plus this into this, 0. Right? This into this plus this into this, 0. This into this minus this, 0. This into this 0. This into this. A square is coming out to be equal to 0. Can you realize over here? Right? Or even if you don't want to check like that, just take 3 by 2 common and you are doing 1, 1, minus 1, minus 1. Right? This is your square of this. That's what you are doing. So 1, 1, minus 1, minus 1, when you multiply with itself, 1, 1, minus 1, minus 1, what do you get? 1 into 1, minus 1 into 1, 0. Right? 1 into 1, minus 1 into 1, 0. Minus 1 into 1, minus 1, minus 1, 0. Plus 1, so 0. This, 0. All will be 0. So your a square is a null matrix. A square is coming out to be equal to 0. Can you see that? If a square is 0, a square is equal to 0. If a square is 0, that means all these terms will be nothing but equal to 0. That means your I plus a to the power of 2022 is nothing but this much. 202C0. This will be 1. I to the power 2022 will be I only. Any power of I will be I only. So this will be I. Plus this will become 2022 multiplied with a. What is my a? 3 by 2, 3 by 2, minus 3 by 2, minus 3 by 2. That's it. Because I to the power 2021 will be I only. So this will be my final answer. That's it. 1011 into 3. So 3033. Then 1011 into 3, 3033. Achha, I plus I is also there. Remember this. This is your 1001. Right? Plus this one will become 3033. This will become 3033. Right? This will become minus 3033. This will become minus 3033. So your answer will be 3034, 3033, minus 3033 and 3032. Yes, this will be your answer. Option A will be your correct answer. That's it. That's simple. But this is how you're supposed to solve these type of questions. Otherwise, they'll get very calculative. Other method which students learn is observing the pattern. They'll keep squaring m. They'll keep finding the powers of m and then they'll check the pattern, which is sometimes easy, sometimes it gets very long and lengthy. So better method is break it like this and it'll always come easy to you. Okay. Now, a square matrix P satisfies P square equals, this is a PYQ only, right? Satisfies P square equal I minus P, where I is an identity matrix. P to the power n is equal to 5i minus 8p, then n is equal to what? P to the power something is equal to 5i minus 8p. That's what it is saying. Although this particular question we can also solve with something which we'll be learning later, that is called characteristic equation, but it's okay. We can solve it here also, not a problem. So p square is equal to I minus p, and p satisfies it, right? Now I is an identity matrix, and we need to find, try this once on your own. We just need to find n. So that means you'll have to keep calculating the powers of p. That's how you'll go at n. Try doing this once. For example, if I already know p square, start from p square. You know that p square is equal to I minus p, right? So if you want to find p cube, you'll have to multiply p, that means I minus p, times p, that means ip minus p square. This will be your p cube. So p cube will become ip minus p square. That means ip minus I minus p again. Correct? ip minus I minus p again, no? So p cube will become how much? P plus p, that means 2p, and ip will be p only. P cube will become 2p minus I, right? This ip will be p only. This ip will become p, p plus p will become 2p, and 2p minus I. Now you see here it is 5p minus 5i minus 8p. So you'll have to keep finding the powers. Now if I want to find p to the power 4, for example, I'll multiply p again. 2p minus I multiplied with p. What will I get? 2p square minus ip, that means again p. Now 2p square I already know, 2 into I minus p. Minus p. What will this become? 2i minus 2p minus p, that means 3p minus 2i. Now I have p to the power 4 equal to 3p minus 2i. P to the power 5 will become how much? 3p minus 2i multiplied with p again. This will become 3p square minus 2ip. That means 3p square minus 2p. That means 3 into again p square value, I minus p minus 2p. That means 3i. 3i minus 3p minus 2p. So that will become 5p. So 3i minus 5p. Now can you see, as soon as I'll find p to the power 6, I'll get 5i minus 8p. I'll get 5i minus 8p. That means n is nothing but 6 over here. So these type of questions you'll have to manually check and solve sometimes. Okay. Now let's see one more good question where we can use the technique used in last question again. Now it's saying P is a matrix given and I is an identity matrix of order 3. Alright. Now Q is a matrix for which elements are Qij. Q is also a matrix and Qij are the elements. Q11, Q22, Q33, Q44, Q21, Q23, Q32, all these elements Qij. Right. They are representing elements like this. Is a matrix such that P to the power 50 minus Q is equal to I. P to the power 50 minus Q is equal to I, or I can say P to the power 50 is equal to I plus Q. Correct. So if I'm able to calculate P to the power 50, I'll be able to find out Q also. Or I can say P to the power 50 minus, let's write it like this, P to the power 50 minus I will be equal to Q. Okay. So first aim should be finding P to the power 50. My first aim should be able to find P to the power 50, which is a very high power of P. Now P, how can I write P? Now in P, if I want to write identity matrix plus something, let's write it like this. So I'll create an identity matrix. The basic idea which I learned is representing this matrix whose power I am finding as I plus some matrix. So 1 plus what will give me 1? 0. 0 plus what will give me 0? 0 plus what will give me 0? 0 plus what will give me 4? 4. 1 plus what will give me 1? 0. 0 plus what will give me 0? 0 plus what will give me 16? So 16. 0 plus 4 and 1 plus 0. Now if you see in this matrix, can I take 4 common? 4 is being multiplied over here everywhere. Right. So can I write it like this? P is equal to I plus 4 times A, where my A is nothing but 0, 0, 0, 410. Correct? This will be my A because I've taken 4 common. 4 if you multiply 16, 4 and 4 will come over here. Right? This is my P. Correct? Now can I say P to the power 50 is equal to I plus 4 times of A to the power of 50? Is it wrong saying that? I can say that, right? Are you guys following? Just a minute. Tell me. Any problem till here? Any doubt? This way I can write. Now I can find P to the power 50 now, because I know if this A square, that I have to check whether my A is 0, A square is 0, A cube is 0, what is coming has to be 0. 1, 4, 1 over here. So I'll see what is coming 0. My A is 0, 0, 0, 1, 0, 0, 4, 1, 0. This is my A. So I'll find A square 0, 0, 0, 1, 0, 0, 4, 1, 0. Is this coming equal to 0? No. This is definitely not coming equal to 0. A cube will come out to be equal to 0. When you find A cube now, just check once. I'll show you. This will become 0, 0, 0. So 0. Now 0, 0, 0. Then 0, 0, 0. Okay. Now first, so 1, sorry, 0, 0 and 0. Here also 0. 0, 0, 0. Here also 0. But I think 1, 4, 0, 1, 1. Here we'll get 1. Yes, here we are getting 1. So A cube is coming out to be equal to 0 for sure. Right? You'll see. You can calculate also. I remember this. A cube will come out to be equal to 0. And if A cube is equal to 0, I can simply say P to the power 50 will be equal to 50C0, I to the power 0, I to the power 50, A to the power 0. Right? So I to the power 50, that means I only, plus 50C1, I to the power 49, I to the power 49, A to the power 1. Right? Now plus 50C2, I to the power 48, A to the power 2, A square. Right? Plus, now all the terms are going to be 0 because A cube will come. And now all the terms are going to be equal to 0. So we just need to pay attention on this much. Our P to the power 50 will be equal to this. So this gives us 50C0. That means this becomes 1 into I. That means I. Plus this will become 50. 50 I will be I only. 50 into I into A. That means 50 times A. Plus 50C2. This we will have to calculate. So 50 factorial divided by 48 factorial. So 50 into 49 will come over here. 48 factorial and 2 factorial. So this will become 25. That's it. 25 into 49. Right? This will just become 25 into 50 into 49, correct? No, it will become 50 into 49 divided by 2. Yes, 50 into 49 divided by 2, or we can write 25 into 49, same thing only. So this times A. This times A square. And A square will have to find. A square will have to find over here. Right? There is no other guna. A square will have to find. That will be 0, 0, 0. What was A square coming? Just a minute. 4, 1, 4, 0, 16 will come, right? Because third column, right? 0, 0, 0. 4 into 0, 0, 1 into 1, 1, 4, 0 into 4, 0. It will only be 1. Acha, 4 is also multiplied. 16 is also multiplied over here. Yes, right. So your A square will come out to be something like this. Everything will be 0. Only one element will come here. Just check once, okay? A square you can find. So this only this part, only this much part, minus I. So minus I when we'll do minus I and I also will get cancelled. So 50A, 50 times of A plus 25 into 49 times of A square will be equal to your Q. That's it. You'll get your complete matrix only. You'll get your complete matrix only. I'll show you. There must be a solution. Right. Q plus I. Q plus I will be equal to this. I we subtracted. Right. So finally, you'll get this. Right. In this you have to find final matrix. When you'll get, after adding all this, you just have to find Q31. That means third row first column element, third row second column element, and divided by second row first column element. I'm just saving my time for not doing calculation. Simply you can see 16 times, because P is multiplied, right? Over here A is being multiplied. What was our A? A was this, 4 times A, right? A was being multiplied also with 4. That's why. So finally you'll just have to calculate this element Q31, that means this one, plus Q32, that means this element plus this element, divided by Q21, second row first column, divided by this element. Final matrix when you are getting, right, this element and this element, you have to this plus this divided by this only you'll have to do, and you'll get your answer very easily. That easy this question was. There was nothing difficult. It's just how you are calculating the higher powers of matrices. So try solving this once on your own. I'm just not doing the calculation over here. You can do the calculation very easily, right? 25 into 49, multiply it inside A square, and 50A. Add both of them. That will be equal to your Q, because I and minus I will go away, will vanish without any problem. Okay. So that's it. Let's do some more questions. Now, next part, associative. Yes, matrices are associated. You do A into B and then multiply them with C, or you multiply A with the product of B and C, same thing, won't matter. Associative they are not commutative. That means A into B will not be equal to B into A for all the cases. General case, it won't happen. That's it. Distributed over addition, that means you can distribute a multiplication over addition inside matrices also. A multiplied with addition of B and C is A multiplied with B plus A multiplied with C. Obviously it's quite intuitive also. These type of things are quite intuitive also this way. So they are associative, and addition is distributed. Addition and subtraction are distributive over matrices without any trouble. Multiplicative identity, this we already spoke about. Identity matrix of same order multiplied with a matrix, right? If we multiply a matrix with an identity matrix of same order, the result will be same as identity matrix multiplied with that matrix. Simply, in the simple words, IA will be equal to AI. Just the case is that matrix of A and the identity matrix are same. Sorry, order of A and the identity matrix are same. That's the only condition in this case. So multiplicative identity exists. Any matrix multiplied with null matrix will always give a null matrix. You multiply any matrix with zero matrix, the value we are not getting, we'll get a null matrix. Will not write, suppose A is multiplied with B, where B is a null matrix. If B is a null matrix, then A into B will be a null matrix. That's it. All elements will be zero. Its value being 0 is not the correct statement to say. A cross B is null matrix, then it is not necessary that A or B both are null matrix. Very important thing. Very important thing. Suppose A multiplied with B is giving you a null matrix. This does not mean that A and B both are null matrix or either of them is a null matrix. You can get null matrix even if A and B both are not null matrix. Very important statement. Try to understand it. You can get a null matrix on multiplying A and B even if A and B both are not null matrix, right? It can happen. That must be in your intuition that yes, this can happen. Some subtraction and addition can happen and give you final values of all the elements in zero, as zero in the resulting matrix. So that can happen. This does not mean A or B have to be a null matrix. Alright, simple property. Now relation between matrices and determinants. Value of matrix is found by its determinant. We find the determinant of square matrix only. Very important. Determinant is only of square matrix. Have you found a determinant of non-square matrix? right? Determinant itself is the value of square matrix. We have studied in determinants also, if you have studied determinants earlier. If A and B are two square matrices of the same order, then determinant of A multiplied with B will be equal to determinant of A multiplied with determinant of B, right? If A and B are two matrices of same order, then only we can multiply, and determinant of A multiplied with B will be equal to determinant of A multiplied with determinant of B. Very important thing. A to the power n, if we are taking determinant over matrix to the power n, or if we are finding the determinant of matrix and then putting power n to it, both will be same cases, because these are values. These are values. Okay. For example, when we were doing p to the power 50, right? This is going to be a matrix. Now, if we do p to the power 50, we find p to the power 50 determinant, or we find the determinant of 50, determinant of p, and then put power 50 over it. It will be the same thing. Just now when we did a question in which we were finding p to the power 50, that was a matrix. If you want to find determinant of it, then over here k multiplied with an, k multiplied with an. Determinant I'm going to tell you, don't worry, determinant also will study, but right now very few concepts of determinants are coming. Please grasp them, and then we'll be studying determinants also. K times determinants. Remember, in determinants, if you are taking k common out, then k will come out from each row. So if there are 3 rows, if it is a 3 cross 3 matrix, right, and k is multiplied everywhere, k is multiplied everywhere, so k will come out common from first row, second row, and third row. So what will come out common? K to the power 3 will come out common, because they are 3 cross 3 matrix. If this matrix is of n order, that means n cross n, and from determinant if I am taking k out, then k to the power n will come out, right? It's not a matrix, this is a determinant. If from determinant I am taking k out, then k to the power n, where n is the order of matrix, k to the power n will come out as common, right? Okay, are we clear? Okay, simple things. With questions we'll be more clear on them. Now for example, this is a 3 cross 3 matrix, right? This is a 3 cross 3 matrix. If you want to multiply k inside, so k, everywhere you'll multiply k inside. Now if you are finding the determinant of this, this matrix and determinant of this matrix, so what will you take? K common from first row, k common from second row, k common from third row. This is how we take common in determinant. So k cube will come out, and these elements will be as it is. Now how to find the determinant for somebody who does not know, I'll tell that also. 1 2 3 2 minus 2 0 3 5 and 1, right? You take first element, you take this element, hide this row and this column, hide this row and this column, multiply this with this, minus this with this. So 1, this element we are taking, so this row and this column we are hiding. Minus 2 into 1, minus 5 into 0, so minus 2 into 1, minus 5 into 0, 0 only. Now in the case of second one, this one, put a minus, so minus over here, right? 2 we are taking, so 2 as it is. Hide this row corresponding to 2, this is corresponding to 2, so this and this will hide. 2 into 1, minus 3 into 0, so that is 2 only. Plus minus and then plus. Now 3 will take this one and this one will hide. 2 into 5, 10, minus 3 into minus 2, that means minus 6. 10 minus minus 6, that means 10 plus 6, that means 16. So minus 2, minus 4, plus 48 will be your, so minus 6 plus 48, that means 42 will be the value of your determinant of this particular matrix. This is how you find the value. Okay, although we won't need it right now, but still. Transpose, very important concept. Transpose. Suppose you have a matrix of, let's say 3 cross 4, that means 3 rows and 4 columns. Okay, randomly putting the elements 1 2 3 4 3, 4, 1, 2, 6, 7, 9, 3. Right? This is your matrix. Transpose means interchange the rows and columns. This is your, let's say, A. Transpose just means interchange the rows and columns. Whatever is row, make it a column. Right? So if order is 3 cross 4 over here, the transpose order will be 4 cross 3. The transpose order will be 4 cross 3. That means 4 rows and 3 columns. How? First row will become first column. So 1, 2, 3, 4. Second row will become second column. So 3, 4, 1, 2. 6, 7, 9, 3. Third row will become third column. If you go row wise also, if you go column wise also, first column is your first row, 1, 3, 6, 1, 3, 6. Second column, second row, third column, third row, fourth column, fourth row. Rows and columns are interchanged. That's it. So I cross j will become j cross I. Remember that. Transpose means just interchanging the rows and columns. That is the meaning of transpose. Understand that very carefully. Now, A transpose, transpose of A transpose. Suppose if I'm taking 1, 2, 3, 4, 5, 6, I'm taking transpose of this. This is my A. So A transpose will become what? 1, 4, 2, 5, 3, 6. Right? This is 2 into 3. This is 3 into 2. Right? Order is 3 into 2. This is my transpose. Now, if I take transpose of A transpose, that means I transpose this also. So what will happen? Row will become column. 1, 4 will come here. 2, 5 will come here. 3, 6 will come here. What is this? This is again same A. So if I take transpose of A transpose, I'll again get the same matrix. A plus B transpose of A plus B, or I separately transpose A and separately transpose B. That's going to be the same thing. Very important properties. Questions come from the properties of transpose. K into A, K into A, transpose of K into A, or I take K common and find the transpose of A. Both are same things where K is a constant. This one is very important. AB transpose will be B transpose into A transpose. Transpose of AB will be equal to B transpose into A transpose. So reverse is being applied over here. Here also ABC transpose if you are doing, then it will be C transpose, B transpose, A transpose. The order will change. The power can go inside and outside of transpose. Right? Transpose of P to the power 50. Right? Or finding P transpose and then putting power 50 to it is the same thing where P is a matrix. Where P is a matrix. Here P is a matrix. Okay. So P to the power 50 transpose or P transpose to the power 50, both are the same thing. Does not matter how you write it. So very important and applicable properties, because entire matrix chapter is just about its properties, nothing else. Now some important things, some more important things like symmetric and skew symmetric matrix. So if my A transpose is equal to A, if the transpose of A is equal to A, then I'll call it a symmetric matrix. Simple terms, symmetric. If my A transpose is equal to negative of A, then I'll call it skew symmetric. Then I'll call it skew symmetric. If my A transpose is equal to A, obviously same order n, right? Then my square matrix will be called as symmetric matrix. Symmetric and skew symmetric, we'll only talk about square matrix. When we are talking about symmetric or skew symmetric, they are only square matrix can only be symmetric or skew symmetric. If A transpose is equal to A, that means I have a symmetric matrix. If A transpose is equal to negative of A, that means I have a skew symmetric matrix. For example, over here. Now, condition is for all Aij is equal to Aji. Then that is symmetric matrix. That means if we look at our diagonal element, which is this. Now, Aij equal to Aji. That means A21 should be equal to A12. This is A12 and this is A21. A13 should be equal to A31. This is A13. This is A31. A23 should be equal to A32. This is A23. This is A32. For all I and j, if Aij is equal to Aji, right? Then we have a symmetric matrix. Okay, very simple to understand. If Aij is equal to negative of Aji, for example over here, Aij is equal to negative of Aji for all I and j, right? Leave the diagonal elements. For diagonal elements, I and j are equal, right? Here I and j are not equal, right? For except diagonal elements, this is A12 and A21 is negative of A12. This is A13, A31 is negative of A13. A23, A32 is negative of A23. So in this case, we'll get a skew symmetric matrix. Now, if we find the transpose of this, right? If we find the transpose of this, what will be the transpose of this? 2, 1, 3, 2, 1, 3. 1, 0, minus 2, 1, 0, minus 2. 3 minus 2, 5. So 3 minus 2, 5. Now tell me, aren't they same? They are same. A transpose is equal to A. That means this is your symmetric matrix. Now, in this case, A transpose will be equal to negative of A. Let's see, 0 to 4. So 0 to 4. Minus 2, 0, minus 3. Minus 2, 0, minus 3. Minus 4, 3, 0. So minus 4, 3. Now, in this, if we multiply, if this one we multiply with a negative sign, we'll get this thing only. If this one we multiply with a negative sign, we'll get this matrix. We'll get this matrix. That means A transpose is equal to negative of A. In that case, we have a skew symmetric matrix. Let's see some questions. For example, let's say we have to prove that this is a symmetric matrix, right? So A plus A transpose, half of A plus A transpose is a skew symmetric matrix. Symmetric matrix. To prove symmetric or skew symmetric, we have to take transpose of it. So if we take the transpose of this entire thing, let's check what happens. First of all, this will come out. So this will be 1/2 and transpose of A plus A transpose. Now transpose will get distributed over plus sign. Property was there. So this will be A transpose plus A transpose transpose, right? That will be equal to half of A transpose plus A transpose transpose. That means A only again. A transpose plus A or A plus A transpose are the same thing. So if we are taking, this is our matrix. If this is C, then C transpose is equal to C again. If we take this as C, then C transpose is equal to C again. That means this is a symmetric matrix. That's how we prove in the questions. Suppose this one, we want to prove that this is a skew symmetric matrix. So we'll take transpose. Let's say this is C. C is what? Half of A minus A transpose. Now C transpose will become what? Half of A minus A transpose whole transpose. This will become half of A transpose minus A transpose transpose. That means A. Transpose will get distributed, right? A transpose transpose, that means A. So this is equal to what? Minus of A minus A transpose. Because in addition, A transpose plus A or A plus A transpose, both are same thing, right? But in subtraction, you'll have to take negative sign common. So what do you get? Your C transpose is equal to negative of C. This is negative of C. That means this matrix is your skew symmetric matrix. This matrix is your skew symmetric matrix. As simple as that. Now, remember this remark. Every square matrix A can be represented as a sum of symmetric and skew symmetric matrix. Although very rarely used, but yeah, this is a property. Every square matrix. Sir, should I buy any online coaching or should I just follow the channel? Yeah, YTGT, you can follow the channel for now. On the channel also, I know that you follow the channel, beta. On the channel also, no, after our April, after second week of April, everything is going to be taught once again with questions, and more discussions are going to be there. So yes, definitely you can rely on the channel. Keep updated with the channel, keep learning on the channel, keep letting us know what you need to learn right now or any specific topic or something. More than that, you will have to, I'll tell you, like just wait for 1 or 2 weeks. I'll tell you the books also which you can follow. Okay, some books also you should solve so that you can make sure that your attempt is cleared. Okay, and definitely yes beta, you keep following the channel, we'll keep teaching and we'll keep solving, keep letting us know what's happening, and we'll keep updating you, don't worry. Okay, for plus 2 it will be more than sufficient, don't worry about it. Okay, now so this is one thing, that every matrix can be represented at sum of A plus A transpose and A minus A transpose, sum of these two. You solve this, you'll get same thing, only half A will become A transpose minus A transpose will become 0. So A equal to A we are getting on both the sides. So I don't think you'll get to use this anywhere, but remember this, that's in some specific question where you are required. I have no experience of such a question where you required this, but still generally in books this is being told, so I'm also telling that any matrix you can represent in this form, half of A plus A transpose plus half of A minus A transpose. That means symmetric matrix and its skew symmetric matrix. That means if A is a matrix, then half of A plus A transpose will be a symmetric one and half of A minus A transpose will be a skew symmetric one. If A and B are symmetric matrices of same order, then prove that AB minus BA is skew symmetric. This also you can do. Try doing once on your own. Very easily you will be able to do. Just take transpose and you'll be able to do. Don't worry. A and B are symmetric. So A and B are symmetric means A transpose will be equal to A and B transpose will be equal to B. That's it. Just take AB minus BA transpose. What do you get? So you'll get AB transpose minus BA transpose. What will this become? B transpose into A transpose. Right? What will this become? A transpose into B transpose. Correct? What is B transpose? This is equal to B only. A transpose is A only. Minus A transpose is A only. B transpose is B only. BA minus AB. This is what we are getting. So AB minus BA is negative of BA minus AB. That means that this matrix is a skew symmetric matrix. Very easily these questions can be proved. So try them. Few of them I'll be leaving for you. JEE Advanced. Wow. Amazing. See, JEE Advanced asked a question on symmetric and skew symmetric matrix. Can you try solving this? Come on, give it a try. Come on, give it a try. Bhai, simply you just have to check. It's a multiple correct question. Say there is only one way of checking, bhai. There is only one way of checking. What are they asking? That 3 cross 3 matrix is X and 3 cross 3 matrix is Y. These are two non-zero skew symmetric matrix. Okay, skew symmetric matrix. That means X transpose is equal to negative X and Y transpose is equal to negative Y. Right? That's what they are saying. Skew symmetric na? Matrices. And Z is a non-zero symmetric matrix. That means Z transpose is equal to Z. This much only you'll need to check all the options. Which of the following is skew symmetric matrix? For example, this one we want to check. So y cube z to the power 4 minus z4 y cube. Just take transpose of it and check whether you are getting the same thing or a negative one. If you are getting the same thing, then it's symmetric, not skew symmetric. Let's see. So y3 z4 transpose, will break the transpose, minus z4 y3 transpose. So this will become Z transpose to the power 4 Y transpose to the power 3 minus Z transpose to the power, ulta I'm writing, minus transpose, this will get reversed, right, according to the property. AB transpose is B transpose into A transpose. So that's why. And I'm taking the power out. So this will become Y transpose Q multiplied with Z transpose to the power 4. Now Z transpose is Z. So Z to the power 4, Y transpose is negative Y. So negative Y to the power 3. Minus Y transpose is negative Y. Negative Y into minus will become plus Y to the power 3. Z transpose is Z only, so Z to the power 4. So what do we get? Z4 Y3 minus Z4 Y3. Ulta, something wrong kya? Ha, correct. Z4 Y cube. Something wrong. Arey, ulta. Here I have written ulta. So, oh no, yaar. I've written sahi only, correct only. What is happening? Z. This will become Z transpose to the power 4 Okay. So Z transpose, that means Z to the power 4 minus, so Y to the power 3. Z to the power 4, Y to the power 3, correct. This will become plus Y to the power 3, Z to the power 4. Yeah, correct. So we are getting Y to the power 3, Z to the power 4 minus Z to the power 4, Y to the power 3. Don't say it is 0. ZY and YZ are not equal. Matrices we are learning, right? ZY and YZ are not equal. But we know that this is exactly, transpose of this is exactly equal to this. That means this is symmetric. Similarly, this will also come out to be symmetric. You can check, right? Because X transpose will be equal to minus X, Y transpose will be equal to minus Y. So minus, if you will take common, right? X to the power 44, X to the power 44 plus Y to the power 44 whole transpose, if you find out, what do you get? X transpose to the power 44 plus Y transpose to the power 44. Correct. X transpose is minus X to the power 44 plus minus Y to the power 44. But the powers are even, so minus will become plus. So we'll get the same thing again. That's why this is also symmetric. These two will come out to be as skew symmetric. We'll check. Yeah, these two will come out to be as skew symmetric, right? You can check. The third option, when you apply transpose, you'll get negative of this same thing. That means skew symmetric. And for the fourth option also, because the power is odd, you'll get a skew symmetric matrix. Okay. So in advance also, very basic and easy questions can be asked from symmetric and skew symmetric. It's just about you should be thorough with the concept. You should be well practiced with these questions. Number of symmetric matrices of order 3 with all the entries from this. Symmetric matrices you need to make, right? Order 3. That means something here, 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 something here. 3 cross 3. Order 3 means 3 cross 3 only. Okay. Now you need to pick up the elements from these and fill in these. But your matrix should be symmetric. That means whatever is coming at the blue place should be same. Whatever is coming at the green place should be same. And whatever is coming at the pink place should be same. Correct. Now, how many options do we have to fill this one, and this one from these? Obviously, any one element we can fill. So 10 options for this one, 10 options for this one, 10 options for this one. In diagonal, we don't have any boundation. For making it symmetric, only this and this element should be same. So 10 options for this one. Elements can repeat. There is nowhere written that elements cannot repeat. 10 options for this one. But for this one, whatever is filled here will be filled here also. So 1 option for this one. Similarly, 10 options for this one and 1 option for this one. 10 options for this one and 1 option for this one. So how many 10s do we have? 10 to the power 6 will be our final answer. 10 to the power 6 ways are there to make a symmetric matrix over here using these elements. That's simple. This question was asked in 2023 mains. Simple. You just need to know. Space not teach in Hindi. Space not I cannot teach in Hindi beta, because this is an English channel and this channel is for the students who learn in English, who have difficulty in understanding in Hindi. Okay, so it's okay. There are many Hindi channels also beta. You can go there. I also teach on some Hindi channels, but here there is a restriction, there is a foundation, there is a condition that we should be learning in English. Sorry. Okay. Determinants of skew matrix of odd order will be equal to 0. What? Determinants of skew matrix of odd order will be equal to 0. How? Can somebody tell me how? By determinant of skew matrix of odd order will be equal to 0. If it is a skew matrix, then I know that A transpose will be equal to negative of A, provided that both have order n. This thing we know, right? Both have order n. Now they are talking about determinant. So I'll take the determinant, right? One thing you should know, right? One thing you should know. determinant of A will be equal to determinant of A transpose. Determinant, not matrix. Determinant of A will be equal to determinant of A transpose. You find the determinant of matrix or you find the determinant of its transpose. They will be same. Obviously, if matrix elements are not changing, then its determinant will also not change. Okay. So this is important. This you should know, right? And is used at many places. Now if I take determinants on both the sides, so determinant of A and transpose will be equal to negative determinant of A. Okay. Now we know that if a constant comes out of determinant, constant to the power of order of determinant will come out, right? If I am having 3A and I am finding determinant and A is order 3 cross 3, right? A is a square matrix of order 3. So 3 to the power 3 will come out. Only 3 will not come out because 3 from first row, 3 from second row, 3 from third row. So 3 to the power 3 will come out. Correct? Now this determinant of A transpose or determinant of A will be equal to, will be same only. Right? Will be same only. But this side, what will I have? If n is odd, then -1 to the odd power will come out, right? Then -1 to the power of n will come out. Now if n is odd, this negative will remain, this minus will remain. If n is even, then minus will vanish, it will become plus. But if n is odd, then minus will remain. In that case, what will I get? Determinant of an is equal to negative of determinant of an. That means 2 times of determinant of an equal to 0. That means determinant of an will be equal to 0, where A is the matrix of order n. That's why they are saying that determinant of skew symmetric matrix of odd order, only when n is odd, then only this minus sign will remain. No, of odd order will be 0. Determinant of skew symmetric matrix of odd order will become equal to 0. Remember that. All right, let's go ahead. Now, two very basic things, although this is not in your syllabus, just for the knowledge I'm telling you, Hermitian and skew Hermitian matrix. These are only applicable in case of imaginary elements, imaginary or complex elements. When you have complex elements in your matrix, which is very rare case, but if you have, then two more things are defined, which are Hermitian and skew Hermitian matrix. Hermitian matrix are those matrices which have complex numbers involved, and in that case we find the conjugate of a complex number. Conjugate of real number is the number itself. Conjugate of complex number, for example, if I want to find I plus 2 conjugate, then it will be I minus 2. Right? If I'm finding the conjugate of 3i plus 2, it will be 3i minus 2. 2 plus 3i, 2 minus 3i. Right? That is conjugate. Now, in transpose of conjugate of a matrix is called transposed conjugate. Right? For example, if this is your matrix which involves some complex numbers, I means iota, 2 plus I minus 1 minus I, 1 plus 2i, 0. This is your matrix, right, which involves complex elements. Then what will be your A conjugate? A conjugate means just a bar over A. A conjugate means take the conjugate, just change the sign of your complex element. Wherever you see plus I, make it minus I. Wherever you see minus I, make it plus I. So I will become minus I, 2 plus I will become 2 minus I, 1 minus I will become 1 plus I, 1 plus 2I will become 1 minus 2I. Rest everything, all the real numbers remain as it is. Right? So this is your A conjugate. And when you take the transpose of A conjugate, this is transpose. When you take the transpose of A conjugate, this will be your transpose conjugate. This will be your transpose conjugate. Right? Now, if your transpose conjugate of A is equal to A, in this case we call it Hermitian matrix. Hermitian matrix. If your transpose of A conjugate comes out to be equal to A, then you have a Hermitian matrix. For example, over here, this one, transpose of A conjugate. This is your A, this is your A conjugate. Now transpose of A conjugate came out to be equal to this. So this is not Hermitian, right? For example, this a square matrix is called Hermitian matrix if transpose of A conjugate comes out to be equal to A, right? For leave this thing, transpose of A conjugate. So this is your A, for example. What will A conjugate become? A conjugate will become 1, 2 minus I, 1, 2 plus I, 2, 1 minus 2I, right? 1, 1 plus 2I and 0. This is your A conjugate. Now transpose of A conjugate. Let's find that. What will be transpose of A conjugate? 1, 2 minus I and 1 will come here. 2 plus I, 2 and 1 minus 2I will come here. Correct? Then 1, 1 plus 2I and 0 will come here. Now check. This and this, are they equal or not? Transpose of A conjugate is equal to A. That's why we can say this is a Hermitian matrix. Now conjugate can only be found when there are complex terms involved. Otherwise, we won't be finding conjugate only. There is no purpose of finding conjugate. So skew Hermitian and Hermitian matrix are only spoken about or are only considered when we have complex elements in the matrix. That's it. Whenever we have complex elements in them, otherwise why will we find conjugate? So transpose of A conjugate, if that comes out to be equal to A, then we call it a Hermitian matrix. And obviously if transpose of A conjugate comes out to be equal to negative A, that means we have a skew Hermitian matrix. You can find it over here. This is your A, right? What will become your A conjugate? A conjugate will become minus I over here, 1 minus I over here, 1 minus 2I over here, right? Here what we'll have? Minus of 1 plus I. Only I sign will change. So this will become negative 2I. This will become 2. This will become negative of 1 plus 2I. Negative of 1 plus 2I. This will remain 2. This will remain 0. Now transpose of this. That means A conjugate transpose if we are finding. So this will become negative I, 1 minus I, 1 minus 2I. Correct? Here we'll have negative of 1 plus I. Right? Here we'll have negative 2I. Here we'll have 2. Here we'll have negative of 1 plus 2I. Here we'll have 2. Here we'll have 0. So if you multiply this with a negative sign, this one with a negative sign, you will exact get this. So transpose of A conjugate is equal to negative of A. That means this is a skew symmetric matrix. Now two major important things to notice in case of a symmetric matrix. In case of Hermitian symmetric matrix, that means in case of Hermitian matrix, always diagonal elements will be purely real. Diagonal elements will have to be purely real in case of Hermitian matrix. And in case of Hermitian skew matrix or skew Hermitian matrix, the diagonal elements will be purely imaginary. And this is very intuitive also, right? Otherwise, how will the conjugate will be equal to negative of that? So in case of Hermitian matrix, the diagonal elements are always purely real. In case of skew Hermitian matrix, the diagonal elements are always purely imaginary. In case of Hermitian matrix, your conjugate of A transpose will be equal to A. In case of skew Hermitian matrix, transpose of A conjugate will be equal to negative of A. Transpose of A conjugate will be A for Hermitian. Transpose of A conjugate will be equal to negative A for skew Hermitian. In Hermitian matrix, all diagonal elements have to be purely real. In case of skew Hermitian matrix, the diagonal elements have to be purely imaginary. Alright. So this was small part, although very rarely used, but for information you must know, because once in advance they asked a question on Hermitian and skew Hermitian matrix. That's why I told this particular concept also. Now, what is orthogonal matrix? Orthogonal matrix means when you multiply A with its transpose, you get an identity matrix. if you are multiplying a matrix with its transpose and the result is becoming an identity matrix, then A will be called as an orthogonal matrix. Then in that case your matrix will be called as an orthogonal matrix. Okay, A into A transpose is equal to I. Very important thing. Now whenever this is the case, what happens? How do we use? If A is an orthogonal matrix, then its determinant must be equal to plus or minus 1. If A is an orthogonal matrix, then its determinant must be equal to plus or minus 1. How? Let's take determinant on both the sides. A into A transpose. Determinant is equal to determinant of I. Just taking determinant of I will be equal to 1 only, right? Determinant can be broken over here. A, determinant of A transpose will be equal to 1. A transpose determinant or A determinant, same thing only. So determinant of A square will be equal to 1. That means determinant of A will be equal to plus or minus 1. That's how we are saying. But this does not apply that, write it down somewhere. This is also important to understand. Arey, what happened? Why is this stuck? This is also important to understand that determinant of A equal to plus or minus 1 does not mean, this does not mean that A is orthogonal. Vice versa we cannot say. This is not true both ways around. Determinant of something can be equal to plus or minus 1. Determinants of a matrix, determinant of any matrix can be equal to plus or minus 1. That does not mean that A is orthogonal. But yeah, we can say if A is orthogonal, then definitely its determinant will be equal to plus or minus 1. But saying other way around will not be true. Remember that. Saying it other way around, that means saying that if determinant of a matrix is equal to plus or minus 1, this does not mean that A is going to be orthogonal. Nowhere it means that A is going to be orthogonal. Okay, remember that. So now, very important thing about orthogonal matrix. If question comes on orthogonal matrix, you must know a few things. First thing, that if it's an orthogonal matrix, then its determinant will be equal to plus or minus 1. Okay. Second thing, that every row, if you find the determinant of any row or any column, right? If you find the determinant of column, not row, actually column, yeah. If you find the determinant of column, it will always be equal to 1. What will be the determinant of this column? It will be equal to 1 by 2 whole square plus root 3 by 2 whole square plus 0 square. What is it? 1 by 4 plus 1 by 4 plus 0. That means, oh sorry, 3 by 4. That means equal to 1. Right? Here also you can check. Here also you can check. 1 by 2 whole square plus minus 1 by 2 whole square. 2 by 2, 1. Minus 1 by root 2 whole square plus 1 by root 2 whole square. 2 by 2, 1. Right? So when you suppose if your this thing A, B, C, D, E, F, G, H, I, if this is your orthogonal, if it's orthogonal, then two things you can say, right? Let me write, it's on another page. Suppose if your this matrix, it's square or non-square, don't worry about it. But if A is orthogonal, if this is orthogonal, write two things. Right, very important things for solving questions. Two things will definitely be correct. First thing is that A square plus B square plus G square, this will be equal to 1. And similarly for square root of B square plus E square plus H square and square root of C square plus F square plus I square. These all will be equal to 1. First thing. Then AB plus DE plus GH will be equal to 0. dot product, vector product of these two columns AB plus DE plus GH will be equal to 0. Similarly, BC plus EF plus HI will be equal to 0, and similarly AC plus DF plus GI will be equal to 0. These things and this thing both are important. Note them down. Note them down. Very important thing for solving the questions based on orthogonal matrix, because if you remember these two, you'll solve your question in time. Otherwise it will take a lot of time. You'll keep thinking about A into A transpose is equal to I, so that won't give you much of result. Okay, dot product you can check also over here. 1 into 0 plus 0 into 1 plus 0 into 0, 0. 1 by root 2 into minus 1 by root 2, that means minus 1 by 2. Minus 1 by 2 into 1 by root 2, 0. Correct? Here also you can check this into this plus this into this, 0. Now check over here. Is this true over here? Check over here. Is this true? Is this true? This is I think there should be a negative sign here also. Yes, this is not true. For this one it's not true. Now it will be true. There should be a negative sign over here. So this into this plus this into this, now it is 0. So now it is an orthogonal matrix. There should be a negative sign. There is a mistake. There should be a negative sign for sure. Okay, correct. So A square plus D square plus G square square root will be equal to 1. Mod of the columns will be equal to 1 and dot products will be equal to 0. If you have studied vectors and sum of determinants, then you'll understand this. Now let's see some questions. A multiplied with A transpose is I, identity matrix of order 3. That means it is orthogonal. Then determinant of P is what we are supposed to find, or mod of P. Actually not determinant of P, because P is an element. So mod of P we are supposed to find. That's it. If A into A transpose is identity matrix, that also of order 3, that means A is orthogonal. One thing we can say that A is orthogonal. Right? If A is orthogonal, then 0 square plus P square square root should be equal to 1. That means square root of 2P square should be equal to 1. That means 2, right? Square root of 2P square should be equal to 1. So 2P square should be equal to 1. That means P square should be equal to 1 by 2. That means mod of P should be equal to plus or minus 1 over root 2. 1 by root 2 plus or minus 1 by root 2. That means if mod we are finding, that means plus 1 by root 2. Correct? That's simple. If you know the properties, this is a PYQ from 2019. If we have used this, then only we have come out this fast. Otherwise, you'll keep doing A into A transpose is equal to I. You'll find transpose, then multiply, then some relation in P, then a quadratic equation in P, and finally you'll get the answer. That'll be very long. Okay, remember that. Now, for example, this question, again, this is also a PYQ or a good question from a good book. Now, look at this. What is given? AIBI, sum of AIBI from I equal to 1 to 3. So what does this mean actually? Right? Sum of AIBI from I equals 1 to 3. This just means A1 B1 plus A2 B2 plus A3 B3. Correct? This is what it means. Sum of BICI from I equal to 1 equal to 3. This is equal to B1 C1 plus B2 C2 plus B3 C3. This is also equal to A1 C1 plus A2 C2 plus A3 C3. What did we learn over here in this one? Two things we learned, right? AB, A1 B1, right, plus A2 B2 plus A3 B3. A into B plus D into E plus G into H will be equal to 0, plus This into this, this into this, this into this will be equal to 0. This into this plus this into this plus this into this will be equal to 0. Isn't it saying the same thing? Isn't it saying the same thing? A11, A1 into B1 plus A2 into B2 plus A3 into B3 is 0. B1 C1 plus B2 C2 plus B3 C3 is 0. A1 C1, A2 C2, A3 C3, this is also equal to 0. This is what it's saying. So that means one property is satisfied of orthogonal matrix. Now what is this saying? A1 square plus A2 square plus A3 square. That means A1 square plus A2 square plus A3 square, B1 square plus B2 square plus B3 square, and C1 square plus C2 square plus C3 square is equal to 1. That means your matrix, this complete matrix is nothing but orthogonal. This is your orthogonal. Right? Both the properties are being satisfied. That means this is definitely orthogonal. And if this is orthogonal, then its value will be, its determinant will be plus or minus 1. However complicated the question is, will April attempt be hard or easy? It will be harder than the first attempt, beta. Definitely is. That's the trend. Not very hard. Okay. If you are prepared, not that hard also. If you don't know this property, no, you'll have to do this much of manipulation. Okay, generally. So two basic things you need to know about orthogonal matrix. Very, very easy and applicable. Okay, do them. Now, let's see this. Hey, this question is not related here, although, but okay, let's see. If P is some matrix, A is some matrix, A is not identity, okay? 1, 1, 1, 3 ones are there. And Q is this, PA, P to the power T. Or PA, P transpose, sorry, what P to the power? P transpose Q to the power 2007 and P is equal to some ABCD. Then, so we need to find P transpose Q to the power 2007, okay, multiplied with P. This is what we are supposed to find, right? This is what we are supposed to find. Okay, correct. This matrix we need to find. So here what we can do is P transpose into P. Now if we look at P, here this question is actually very good. Why? Because you have to be very observative in seeing that P is orthogonal. Can you see that P is orthogonal? And orthogonal means P into P transpose will be equal to I. Isn't it orthogonal? Root 3 by 2 whole square plus 1 by 2 whole square will be equal to 1. Root 3 by 2 into 1 by 2 plus minus 1 by 2 into root 3 by 2 will be equal to 0. Dot product is 0 and mods are equal to 1. Okay, so P transpose into P transpose is going to be equal to I. And obviously P into P transpose will be equal to P transpose into P also, because it's a square matrix. P transpose into P will be equal to P into P transpose if it's a square matrix, right? Know that. Generally by solving we know that, but if not, then you should know, right? Now P transpose into Q to the power 2007. Q to the power 2007. What is Q? Q is over here, right? Q is over here. Q to the power 2007 we have to do. Can you do this question? I think easy, right? Wait, Q to the power 2007. So simply do P transpose into Q. What is Q? PAP transpose to the power 2007 into P. This will be equal to what? P transpose into P is I. P transpose into P is I, and here P into P transpose is also equal to I. So P transpose into P became I, and P into P transpose became I. I into A, that means A only. So basically we are just finding A to the power 2007. That's it. We just need to find A to the power 2007 because P transpose into P became equal to I because P is orthogonal. And then here inside P into P transpose also became I. So only A is remained. I we don't have to multiply. I multiplied with any matrix will give you same matrix. So A to the power 2007 only we need to find, and that we know how to find very easily. 1 1 0 1. So simply just look at the pattern. So this is your A. So A square, let's find. How will you do? A is this 1 1 0 1. So find A square and observe the pattern. What is A square? A square will be equal to A square will be equal to, I think, 1 2 and yeah, 1 2 0 1. Just check once. Okay, 1 2 0 1 will be your A square, and A cube will come out to be 1 3 0 1. So A to the power 2007 will be nothing but 1 2007 0 1. Right, this will be nothing but 1. Here we'll have 2007, here 0, here 1. A square has 2 over here, A cube has 3 over here. So A to the power 2007 will be this thing. A, B, C, D, 2 times 1 plus B, that means 2007, minus 3 times 0, so 0, right? Minus 4 times D, that means minus 4. Minus 2, 2007, minus 2, 2005 will be your correct answer. That's it. That simple this question was. But you have to quickly observe that that is an orthogonal matrix. Then only this question can be made. Questions of matrices and determinants are not calculative, guys. They are not. They are made calculative by you only. Okay. Some special matrices we should know about. Unitary matrix. A square matrix is unitary matrix if A multiplied with transpose of A conjugate gives you I. This obviously will be applicable in case of complex numbers. In case of real numbers also it will be applicable because conjugate will remain same. A into A transpose is equal to I. That means this is a orthogonal matrix, and A multiplied with transpose of A conjugate is equal to I. Then it is also a unitary matrix. Then it is also a unitary matrix. Idempotent matrix, a square matrix is called idempotent if A square is equal to A. Now if A square is equal to A, then what will be A cube? A cube will be A square into A. That means A cube will be A square is already A, so A into A. So that means A cube will be equal to A square, which is also equal to A. So if A square is equal to A, any power of A now will be equal to A for all n greater than or equal to 2. In these type of matrices are called idempotent matrices, whose powers remain same, right? They remain same on increasing the power over them. If A square is equal to A, then A cube will also be equal to A to the power 3 will also be equal, A to the power 4 will also be equal to A to the power 10 will also be equal to A. And these type of matrices are called, we have seen these type of matrices while solving the questions. We have seen this type of pattern. Okay, these type of matrices are called idempotent matrices. Very important. This question we have solved actually, right? We have solved. If AB is equal to A and BA is equal to B, then show that B is idempotent matrix. B is idempotent. That means B square. What is B square? B square, right? If you find B square over here, right? If AB is, show that B is an idempotent matrix, that means B square should be equal to B. So you can use any one of them. This is what we did. AB is equal to A, right? So multiply B both the sides, BAB. That means now BA is equal to B. Given, so B into B it will become, and BA is equal to B. B will come B square equal to B. Very silly type of question, just add it for the knowledge. Involuntary matrix. If A square comes out to be equal to identity, then this is called as this will be called as involuntary matrix. So idempotent and involuntary, two things. Idempotent means sometimes they might give you in a question that A is an idempotent matrix. That means A square is equal to A. Or they might give you A is an involuntary matrix. That means A square is equal to I. So remember these names. Okay, it's very important to know and remember these names, that which type of matrix are we talking about. Involuntary matrix means A square is an identity matrix. Idempotent matrix means A square is equal to A. Two very important names, idempotent and involuntary. Nilpotent matrix, no need, you don't need to know this. This, I'll just tell you what does it mean. It says that if A plus A square plus A cube, it's saying that suppose there is a matrix for which A cube is equal to 0, but A square is not equal to 0. Or let's say a to the power 5 is equal to 0, but a to the power 4 is not equal to 0. These type of matrices are called nilpotent matrix. Idempotent matrix means if a square is 0, then a cube, a cube, a to the power 5, every power will be equal to 0. But there can be some matrix for which a to the power 5 is coming out to be equal to 0, but before that a to the power 4 was not equal to 0. In that case, that will be called as nilpotent matrix. Idempotent, involuntary and nilpotent. Idempotent means a square equal to a. Involuntary means a square equal to I. Nilpotent means that a, some power of a is equal to 0, but power before that was not equal to 0. Okay. Singular and non-singular. If the value of determinant of a matrix is 0, then it is a singular matrix. If the value of the determinant of a matrix is non-zero, then it is non-singular matrix. That's it. A matrix is called singular if its determinant is 0. It's non-singular in any other case. If the determinant of matrix is coming out to be equal to 0, then that matrix will be called as your singular matrix. Otherwise, it will be non-singular matrix. Now, next thing, very important, adjoint. How to find the adjoint? Okay, I'll take a small break. I'll be back. Till then, you can revise the previous part or you can also take a break. Now let's talk about very major thing, which is adjoint. First, always try to properly find the adjoint of a matrix. Sometimes, you know, we directly start studying the adjoint and we actually don't realize that do we know how to find the adjoint of a matrix, because this part is very important, right? This year also, if you see, no, the questions which came in JEE Mains mostly are from adjoint of matrix only. This particular part, most of them are from adjoint of matrix, and very easy part. This is not very difficult, right? Let's learn first how to find the adjoint and what does it mean for any square matrix. Adjoint will be defined for square matrix. Adjoint is defined as transposed of its cofactor matrix. So first, transpose of the cofactor matrix. For example, if we are talking about this matrix, transpose of the cofactor matrix. Cofactor matrix is what? Cofactor matrix of A, or I'm writing cofactor matrix of A. Let's say we are finding, right? Suppose we are finding cofactor matrix of A. So cofactors are like this. First of all, this is A11, so minus 1 to the power 1 plus 1 will be multiplied. This is A12, so minus 1 to the power 1 plus 2 will be multiplied. This is A21, so minus 1 to the power 2 plus 1 will be multiplied, and this is A22, so minus 1 to the power 2 will be multiplied. I'm telling you the formal way of finding the adjoint of a matrix, right? And you should know this, so that sometimes, you know, you might make a mistake in finding the adjoint only, because students studying for JEE do not practice this part. Actually, I know that, right? Minus 1 to the power 1 plus 1, because this is A11, this is A12, this is A21, this is A22, right? So here you will get a negative sign, here you will get a negative sign, correct? So instead of writing this, what if I just simply write minus here, sorry, minus over here and minus over here. I have to multiply. Cofactor of 4. Hide 4 corresponding rows and columns. What is remaining? 5. So cofactor of 4 is 5 with plus only. Cofactor of 1. Hide corresponding row and corresponding column. What is remaining? Minus 1. Minus into minus 1 will make it plus 1. Cofactor of minus 1. Hide this and this. What is remaining? 1. 1 with a minus, so minus 1. Cofactor of 5, this element. Hide this and hide this. What will remain? Minus 1. Minus 1 with a positive sign, that means minus 1. So this is cofactor matrix of A. And then adjoint of A will be equal to transpose of this. Right? Cofactor of A transpose. That means transpose of this. That means 5, 1, minus 1, minus 1. This will be your adjoint of A. This will become as your adjoint of A. Wait. Here it will be 4, right? Hiding this and this, so this will be 4. 4 with a positive sign, so 4. Yeah, this will be 4. This will be 4. Cofactor of 5 is 4, na? This is 2 cross 2, so that's why it was very simple. Right? So this will be your adjoint of A. Let's do it again with 3 cross 3. First we'll find cofactor matrix of B. Okay, where we'll get negative sign. 1, 1, so minus 1 to the power 2. 1, 2, so minus 1 to the power 3. So we'll get a negative sign here. 1, 3, so minus 1 to the power 4. That means positive. 2, 1, minus 1 to the power 3. That means negative. So we'll get a negative sign here. 2, 2, minus 1 to the power 4, positive. 2, 3, that means minus 1 to the power 5, negative. 3, 1, that means minus 1 to the power 4, that means positive. 3, 2, minus 1 to the power 5, that means negative. 3, 3, minus 1 to the power 6, that means positive. So negative sign in a 3 cross 3 matrix will be like this. You must know that. Now cofactor matrix. So cofactor of 1. Hide this one and this one. What is remaining? This and this. 3 into 2, 6, minus 5 into 1. 6 minus 5, that means 1. 1 with a positive sign, so it will be 1 over here. Now, cofactor of minus 2. So to hide this and hide this. What is remaining? 0 into 3 minus 4 into 1. So 0 plus 4 with a negative sign. So minus 4 over here. Right? Cofactor of 4. So hide this and this. That means 0 plus 8 with a positive sign. That means 8. Correct? Right? This way you can find the cofactor of all of these. Cofactor matrix of B first you'll have to make. So what will we get over here? Cofactor of this, hide this and this, right? Minus 2 into 3, minus 6, minus 6, minus 20, minus 26 with a negative sign. That means positive 26. So this is very important part. Okay. Similarly here what will come? 15. Here with a negative sign. So 0 plus 8 with a negative sign. So minus, for 1, right? For this one, let's say I'm hiding this and this we'll have to hide. So 5 minus 8 minus 3 with a negative sign. So positive 3. So we'll get a positive 3 over here. We'll get a minus 10, minus 1, and here we'll get 2. 2. So this will be your cofactor matrix of B. Now adjoint of B will be just transpose of this. That means 126 minus 10, minus 4, 15 and minus 1, minus 8, 3 and 2. This will be your adjoint of B. This should be proper in your heads. This you should be very thorough with. How to find the adjoint. Otherwise, because sometimes basic questions can be asked out of this only. How to find the adjoint. Practice this very carefully. First find the cofactor matrix. In case of 2 cross 2, it's very easy. You just have to change the signs of this one and this one. That's it. Just have to change the signs of this one and this one. Just change the signs of these two. This will become -1, this will become +1, rest everything interchange. 4 will come here, 5 will go there, right? Just interchange and you'll get your square adjoint in case of 2 cross 2. But in case of other matrices of higher orders, you'll have to find like this, like how I taught. Okay, so this was on how to find the adjoint of a matrix. Now few more things. What is adjoint of a matrix? According to a definition, A multiplied with adjoint of A. This is how you write adjoint of A. This is equal to determinant of A multiplied with identity matrix of order n, because A is also a matrix of order n. Determinant of A multiplied with an identity matrix is equal to matrix multiplied with its adjoint, and vice versa is also true. Adjoint multiplied with matrix will also give you the same thing. This is the basic main information, main definition of adjoint of a matrix, which you'll be using in your questions. A into adjoint of A is equal to determinant of A into I, and adjoint of A into A is also equal to determinant of A into I. Right? Some properties of adjoints which you need to know, based on which questions came this year. This year 2025, many questions came on these properties only, on these 3 properties only. What does the property say? If we are finding the determinant of adjoint of A, that will be just equal to determinant to the power of n minus 1, where n is the order of matrix. Where n is the order of matrix. If I am finding the determinant of adjoint of A, it will be nothing but determinant of A to the power of n minus 1, where n is the order of A. Right? Order of A. Very important. I'll show you how these can be proven also very easily, but for right now, it's very important for you to mug them up as it is. Very easily you can prove them just by the definition only. Not a problem. We'll do some other day. But right now, just remember them as it is. If we are finding adjoint of A, it will be determinant of A to the power of n minus 2 times same matrix A. N minus 2 times same matrix A. Determinant of A to the power of n minus 2. 2 adjoints are there. Adjoint inside adjoint. So determinant of A to the power n minus 2 multiplied with same matrix A. This is adjoint of A. There is no determinant. If we put a determinant on this, then this becomes very simple. Determinant of A to the power of n minus 1 whole square. This determinant of A to the power of n minus 1 whole square. And now if this is adjoint of A, let's say this is something like this, and then you are finding the determinant of it. This will be nothing but determinant of A to the power n minus 1 whole cube, because there are 3 adjoints. This particularly was used this year. So now you can make further also. If there are 4 adjoints, then it will be n minus 1 to the power 4. So right now n minus 1 whole cube. Adjoint of A, and determinant if we are finding, right? Simple adjoint of A will be determinant of A to the power of n minus 2, because 2 adjoints are there. If I am simply finding adjoint of A, right? If this is the case, then this will be simply determinant of A to the power n minus 3 times A, which is my matrix, normal matrix, because 3 adjoints are there. So n minus 3 this times. Okay, remember these as it is very useful. Now adjoint of A transpose or transpose of adjoint of A, same thing, very important. Adjoint of A transpose I'm finding, or I'm finding the transpose of adjoint of A, it means the same thing only. Now how to take a constant out, right? Suppose if I have adjoint of 5A and I want this 5 to come out, 5 to the power n minus 1 will come out, where n is the order. Suppose A is of order 3, then 5 square will come out. If A is of order 4, then 5 cube will come out, right? From this adjoint part, k to the power n minus 1 into adjoint of A. Okay, very important again. Adjoint of A to the power m or adjoint of a to the power m or power m over adjoint of a means the same thing for all m belonging to n, means m should be less than the order of a, obviously, right? Adjoint of AB is equal to adjoint of B into adjoint of A, just like transpose, same as transpose. This is same as transpose. Reversal law is being applied here also. In transpose also, AB transpose is equal to B transpose into A transpose. So adjoint of AB will be adjoint of B into adjoint of A. That's it. Remember these, note them down, write them down once on your own, and with questions we'll practice some of them. For example, question this one, a determinant of A is given to you equal to 2, where A is a square matrix of order 3, then find adjoint of A. Adjoint of A is what? Adjoint of A, first property itself, right? First thing, adjoint of A, determinant of A to the power n minus 1. N is the order. What is the order? Square matrix of order 3. Order is equal to 3. So part A, adjoint of A, determinant of adjoint of A will just be determinant of A to the power n minus 1. That means determinant of A to the power 3 minus 1. That means determinant of A square, that means 2 square, that means 4. Part B, determinant of adjoint of adjoint of A. Adjoint of A. We just now learned determinant of adjoint of A will be nothing but determinant of A to the power n minus 1 whole square. Right? Determinant. This one. Determinant of adjoint of A will be determinant of A to the power n minus 1 whole square. That means determinant of A to the power of 3 minus 1, 2 square. That means determinant of A to the power 4. That means 2 to the power 4. That means 16. So these, on the basis of these, many questions can be made and asked from you, right? Now, what will be adjoint of A transpose? Adjoint of A transpose. We have read this property, right? Adjoint of A transpose will be equal to adjoint of A and transpose of it. So it will be equal to adjoint of A and its transpose. So now we know, right? We know that A transpose determinant will be equal to determinant of A, right? Determinant of matrix and its transpose will remain same. That's what we are going to apply over here. So what can I write over here? Adjoint of A transpose and determinant of it, which will be equal to determinant of adjoint of A only. So that was already found, which is 4. Correct? Now D, 5A. First I have to take out 5 from adjoint. From adjoint I have to take out 5. So 5 to the power n minus 1 will come out. 5 to the power 3 minus 1, that means 5 square will come out. So determinant of 5 square adjoint of A. Correct? See, I told you, right? If you want to take a constant out, right? Constant from adjoint. So k to the power n minus 1 will come out. So 5 to the power n minus 1, that means 5 to the power 3 minus 1. That means 5 to the power 2 has to come out. Out of adjoint, not determinant. Out of determinant, now A is going to be a 3 cross 3 matrix. So out of determinant, if it comes out, 5 square to the power 3 will come out. Right? Now 5 square to the power 3 will come out. No, because out of determinant, from all the 3 rows, 5 square will come out common. Right? A is a 3 cross 3 matrix. Adjoint of A will also be a 3 cross 3 matrix. So 5 square coming out of determinant of adjoint of A will come out as 5 square cube, because A is 3 cross 3. So this will be, and then determinant of adjoint of A, which we already know. So 5 to the power 6 multiplied with 4 will be our answer, because determinant of adjoint of A we already found as 4. Right? So 5 to the power 6 into 4, that will be our answer, or 5 to the power 6 into 2 square, however you want to write it. So this is how you solve these type of questions. Practice them, very important. This came in 23, 24, 25 also. Every year it comes. A is a 3 cross 3 matrix, mod of determinant of A is equal to 2, then 3 times adjoint of mod of 3A into A square. Right? Now step by step you'll have to solve this. Step by step you'll have to solve it. First of all, from this 3, A is your 3 cross 3 matrix. First of all, this 3 should come out from your determinant. Right? First of all, 3 should come out from your determinant. So if I'm 3 8 is, this will be 3 cube. 3 cube will come out now. A is 3 cross 3 matrix. From determinant 3 is coming out. So 3 cube will come out. Right? 3 cube determinant of A. Right? Where determinant of A is already given to us. So this will become 3 cube. That means 27 into 2. That means 54 this will be. So what is my problem now? 3 times adjoint of 54 A square. Correct? This is the problem. Yes? Correct? And a determinant over this also. Now 3 I want to take out of determinant. 3 I want to take out of determinant. This 54 also I have to take out. This 54 also I have to take out. So 54, this is what? Adjoint of A square. One property I read over here. Look. Adjoint of A square will be adjoint of A whole squared. Same thing only. Right? Adjoint of A square will be adjoint of A whole squared. Same thing. So now how will you take out this? Think about this. Try to do it once on your own. First take 3 out. 3 will be out. That 3 cube. So now we have adjoint of 54 A square. This is what you have. Right? Adjoint of A, determinant of adjoint of A. Let's say this is some element. This is some K. Adjoint of K it is. Determinant of adjoint of K will be what? Determinant of K to the power n minus 1. Correct? So 3 cube into determinant of 54A square to the power of n minus 1. N is order. That means 3 minus 1. That means 2. Can I write this? Correct? But this is some K. So adjoint, determinant of adjoint of K will be determinant of K to the power n minus 1. So this to the power 3 minus 1, that means 2. Correct? Now any problem? Not a problem. Now 54 also I want to take out. Now 54 has a square. This is what? 3 cube into 54 square into A square square. Correct? This is how I should write. So 3 cube into 54 square coming out of determinant of order 3. So 54 square to the power 3 it will be. 54 square to the power 3 will be there. Correct? And A square square. That means determinant of A square square. A square we know determinant of A square is 4. 4 to the power 2. Determinant of determinant of A is 2. So this will be 2 to the power 4. So your final answer will be nothing but 3 to the power 3 into 54 to the power 6 into 2 to the power 4. So answer is given to you in 3 and 12. 3 and 6. Let's break it. So 9, 6, 3 to the power 6, 3 square into 3, 2. So this will be 3 cube into 2, na? Right. So we can break this as 3 cube into 3 cube into 2 to the power 6 into 2 to the power 4. So that will make us, okay, they have given 6. So 3, 3 to the power 3 into 3 to the power 18. Now we cannot take all 3 to the power 18s. let's make it 3 to the power 4 into 2 to the power 4, so 6 to the power 4, right? It's 18. So now into it will become 3 to the power 56 to the power, so 3 to the power 11 and 6 to the power 10 we are getting. This should be our answer. Break it into 3 and 6 factors. So 3 to the power 11 and 6 to the power 10 will finally come. This you should be reaching at. Rest, everything is fine. You should be able to reach at this. Rest you will be able to do on your own. Don't worry. 3 to the power 3, 54 to the power 6 and 2 to the power 4. Till here you should be able to reach. Rest you can manipulate on your own without any trouble. Sir, is this channel so underrated? Why is this channel so underrated? Even I don't know, beta. Because everybody might be studying for boards maybe. But we have to complete, right? What if they watch it later? Okay. 3 to the power 11 and 6 to the power 10. Yes, correct answer. Right, 3 to the power 11 will come 9, 6. So this will become 3 to the power 3 into 3 to the power 2 into 6 to the power 6. Right, so 3 to the power 3 into 3 to the power 12 into 6 to the power 6. That's it. Right, and this was your so one or twos you can break over here, 3 and 2, and finally you'll get 3 to the power 11 into 6 to the power 10. Come on, let's see one more. This also you'll be able to solve very easily. Again, A is given to you as this and determinant is given to you. Acha, if determinant is given to you, then you'll have to find always be motivated. Thank you, Aswat. Thank you. That's so sweet of you. Now here alpha is something being used, right? And in the question they are asking 3n plus alpha. So n we'll have to find. That we'll find using this relation. But first alpha also we'll have to find. Now then only we can answer. So alpha, for finding alpha, determinant is given. Right? How will we find the alpha? For alpha, determinant is clearly given to us. Right? From this, if we find determinant is clearly given to us. Determinant of A is given to us equal to 2. That means 1 multiplied with 3 into 2 minus 1 into 1, that means 5, minus 2 multiplied with 2 alpha minus 1, that means 2 alpha minus 1, plus 3 multiplied with alpha minus 3. 3 multiplied with cofactors alpha minus 3 should be equal to 2. This should be equal to 2. So 5 minus 4 alpha plus 2 plus 3 alpha minus 9 equal to 2. That gives us alpha minus alpha equals to 7 minus 9 minus 2 equal to 2. So you are getting alpha equal to 4, negative 4. Alpha will come out to be equal to negative 4, right? So just removing this and writing directly that alpha we are getting equal to negative 4. Alpha we have. So your matrix is nothing but you have the matrix, right? Now this thing. How? First take this 2 out, right? 2 is outside the determinant. So 2 to the power, what is the order? 3 cross 3, right? 2 to the power 3 will come out of determinant. Then we'll have adjoint of 2 times the adjoint of 2a. Okay. This is what we are remaining with. Now adjoint of 2a. Now this 2 is also coming. This 2 also we have to bring out from adjoint. This adjoint. Adjoint 2 times something. So 2 to the power n minus 1. That means 2 to the power 3 minus 1. That means 2 to the power 2 will come out. Correct? 2 to the power 2 will come out. Just give me a minute. Yes, sir. अभी थोड़ी सी देर लगेगी. हाँ. एक सेकंड. Guys, try solving this. I'll just be back in a minute. Yeah, sorry. Yeah, alpha we found equal to -4. Now look at this. I'm writing complete thing. 2 times adjoint of 2 times adjoint of 2 times A, and this is what we are finding. Now let's do step by step. Right, first is this 2. Let's take this 2 out of the entire determinant. This 2 is entirely outside. It will come out of determinant. 2 to the power 3, because 3 is the order. So 2 to the power 3 will come out. Adjoint of 2 times adjoint of 2A. Right, this is what we have. Now this 2 should come out of this adjoint. Remember, adjoint of K times A, right, A is order of n, will be equal to, if we are finding the determinants, it will be K to the power of n minus 1 determinant of adjoint of A. Right, if or without determinant also, if you are getting any constant out of adjoint, so constant to the power n minus 1 will come out. Right, so 2 to the power 3 minus 1, that means 2 to the power 2 will come out of this adjoint. 2 to the power 3 into 2 to the power n minus 1, that means 2 to the power 3 minus 1, that means 2 to the power 2 will come out of this adjoint. So 2 to the power 2 will be over here. Right, now this will become adjoint of 2A. Okay, now 2 to the power 2 has to come out of entire determinant. So 2 to the power 2 to the whole power 3 will come out. So this will become 2 to the power 3 into 2 to the power 2 to the whole power 3. Right, this term is coming out of determinant of order 3. So power 3 will be applied. Now this will become adjoint of 2A. Okay, now what does this become? This becomes 6 plus 3, 9. So we have 2 to the power 9 over here. Right, now we remember adjoint of A. If we are finding the determinant of this is nothing but determinant of A to the power n minus 1 whole square. Remember, this and this 2 are very important. Right, so this will become 2A, determinant of 2A to the whole power n minus 1, that means 3 minus 1, that means 2 square, that means 2 square, that means power 4. Now this 2 again has to come out of determinant. Determinant is of order 3. So 2 cube will come out. So this will become 2 to the power 9 multiplied with 2 cube multiplied with determinant of A to the power 4, and determinant of A is given to us. This will become 9, 10, 11, 12. So 2 to the power 12 multiplied with 2 to the power 4. Right, because determinant A is 2, so 2 to the power 4. This will become 2 to the power 16 equal to 32 to the power n. That means 2 to the power 16 is equal to 2 to the power 5n. Correct? Something wrong we are doing, kya? 2 to the power 9 is correct. 3 to 6, 7, 8, 9, correct. 9, 10, 11, 12, 13. 2 to the power 3 will come out, correct. Right, 9, 10, 11, 12. 12 plus 2 to the power of 4, correct. 16 only. N should be equal to 16 by 5. I am getting n equals 16 by 5. No. Eight came out, okay. Then 2 to the power 6. Right. So 2 to the power 6 This came out to square root of 6 came out right. Cube. Arey, something wrong we are doing. Just check once. Oh. 2 to the power 2 will come out. 2 to the power 2 whole cube will come out. That's correct. 6, 9, right? Sorry. Here 2 to the power 3 to the whole power of 4 will come out. Na? Here we are making a mistake. Look, here when we are taking out 2 to the power 3, power 4 is also there. That we forgot. 2 to the power 3 to the power 4 will also come out because power 4 is on the determinant. On this entire thing there is power 4. So 2 to the power 3 from determinant and power 4. So this will become 12 plus 9, 21. Right? 21 this will become. So this will become 2 to the power 21 into 2 to the power of 4. 12 plus 9, 21. Right? And here we'll get 2 to the power 4. So 2 to the power 25 will be equal to 32 to the power n. Yes. 2 to the power 21 into 2 to the power 4 will be equal to 32 to the power n. So this will be 2 to the power 25 equal to 2 to the power 5n. So n will come out to be 5. N is coming out to be equal to 5. And 3n plus alpha, that means 15 minus 4, 11 will be our answer. My bad. Here there was a mistake. Vanakkam Aswath. You are correct. Thank you. Vanakkam. Nalla irkinga. All good? Having fun? Okay. If you find fun in that, that's great. This is question in 2022 they asked. Same, again, adjoint based question. Right? Simple question. Sum of all elements of matrix B they are asking. B is this matrix. I minus 5C1 adjoint of A plus 5C2 adjoint of A square. And till 5. Right? Till 5. So what is basically, if I'm writing this, B is equal to I minus 5C1 adjoint of A plus 5C2 adjoint of A square plus 5C3 adjoint of A cube, right? This is nothing but I minus adjoint of A to the power 5, correct? This B is nothing but I minus adjoint of A to the power 5 because that expansion only is written over here. Can you see that? This expansion only is written over here. First will be 5C0, I to the power 5, right? That will be I only, adjoint of A to the power 0. So only I will remain. Then 5C1, I into adjoint of A to the power 1. Then adjoint of A square. So this is what's written over here. Only that's the catch in this question that you have to pick very quickly. Right? That you have to pick very, very quickly. And then rest of the things you can solve. So now adjoint of A you'll have to find. So A, adjoint of A, if you want to find, then cofactor of A will be equal to, this will be 2, this will be 2, this will be 1, this will be 0. Correct? This will be, and your adjoint of A will become 2, 1, 0, 2. Right? 2, 1, 0, 2 will be your adjoint of A. Cofactor matrix, acha, directly we have done here. We have directly found the adjoint. So adjoint directly we can find, na? With this will just replace. This will become 2, this will become 2, this will become 0, and this will become 1, and this will become 0. 2, 1, 0, 2. This will be your adjoint directly. This will be your adjoint of it. Right? You can find by cofactor also. For 2 cross 2 matrix, adjoint is very easy. Just change the signs of these two and interchange these two. Right? change the signs by interchanging and interchange these two. That's it. So that is your, so your B will become nothing but 0, 1, 0, 0, 1 minus this 2, 1, 0, 2. That's it. To the whole power of 5. This will be your B. That power 5 you know how to find, right? Just observe the pattern and you'll be able to easily find power 5. So this will become nothing but your B will be equal to minus 1, 0 and minus 1 to the power of 5. So I think that will repeat the pattern, right? This is going to repeat the pattern, right? Let's check in the solutions. So your B is this. This is what we got, minus 1, 0, minus 1 to the power 5, correct? And power 5 when you calculate, it will be minus 1, minus 5, 0, minus 1. And sum of elements will be minus 7. There is no direct way. They have calculated by observing the pattern. So in square, there will be a minus 2 over here. In cube, there will be a minus 3. So in power 5, there is a minus 5. That's how they have done. There is nothing amazing or different in this. Okay, simple questions are asked in mains. Remember that. Okay, they are saying for any square matrix, A is n cross n matrix and B is adjoint, then prove that. We can skip this part. No need. This is something else. Inverse of matrix. Now let's come on. Inverse of matrix. Adjoint, be very, very careful, be very, very practiced, especially adjoint of a, those type of things. Practice 4 or 5 questions and get the correct answer. Then only you will be able to stay confident and feel confident in these questions. Otherwise, these questions are going to bother you, and adjoint questions are asked in boards as well as mains. Okay, remember that, even in advanced. Now, inverse of matrix, by definition, it's very simple. A inverse is nothing but adjoint of A divided by its determinant. And it can only be defined if your matrix is non-singular. Because if your matrix is singular, then determinant of A will be equal to 0. And anything divided by 0 is not defined. So that's why inverse can only be defined if your determinant of A is not 0. Or A is a non-singular matrix. B is inverse of A, then A is also inverse of B. If B is inverse of A, then A is also inverse of B. Right? So inverse means A multiplied with B or B multiplied with A is giving you an identity matrix. Right? If A and B are inverse of each other, then A multiplied with B or B multiplied with A will give you an identity matrix. And how to find the inverse? Inverse, or in numbers we call it reciprocal, here we are calling it inverse. Right? Because here it's a matrix. So finding the inverse of a matrix, simple formula only you have to use. A inverse is nothing but first find adjoint of A and divide it by the determinant of A. That's your A inverse. That's it. Right? That's your A inverse. For example, let's find A inverse. So first, for finding inverse, first we'll need to find adjoint. Adjoint of A will become what? So here we'll have 1, here we'll have 2. This will become minus 5, this will become 3. Check whether we have found the correct adjoint. Have we found the correct adjoint? 1 minus 5, 3, 2. Directly you can write the adjoint of 2 cross 2 matrix. This is the way. What do you do? Interchange these two and change the signs of these two. That's it. Interchange these two and change the signs of these two. Interchanged, change the signs. Directly adjoint of A. So what will be your A inverse? A inverse will be adjoint of A divided by its determinant. So determinant also we'll have to find. Determinant of A will be 2 into 1 minus 3 into 5. So that will be equal to 2 plus 15. That means 17. That will be 1 by 17 multiplied with 1 minus 5, 3, 2. This is the inverse matrix of A. And you try multiplying these two. You try multiplying these two. You will get 1. Right? You will get 1 for sure. You will get an identity matrix, not 1. You will get an identity matrix. Okay. AB is equal to BA. Both will be equal to I. A multiplied with inverse will result in an identity matrix. Okay. write it somewhere, that thing also, A multiplied with A inverse will result in identity matrix. Same thing, B is inverse of A is inverse of B. So A inverse is inverse of A multiplied with A inverse will result in an identity matrix. That's by basic intuition also we get this definition. This is how you have to find the inverse. Okay, this is your inverse. For example, let's say in this case, try finding in this case also. First we'll have to find adjoint of B. Adjoint of B will be equal to, so we'll get a minus sign here, here, here and here. Right, at 4 places we'll get a minus sign. So this is 1 1, this is 1 2, 1 3, 2 2 1, 2 3, 3 and 3 2. Right, over here we'll get a negative sign. So let's make first cofactor matrix we'll have to make. Right, so cofactor matrix of B will be what? Write the cofactor of 1, that will be 8 minus 6, 2. Cofactor matrix of minus 1, that will be equal to 0 minus 9, so plus 9, but with a negative sign, so minus 9. Right, this is how you'll have to first form the cofactor matrix of A. First, yeah, one thing before finding the inverse, one thing I forgot to tell you, before starting to find the inverse, always check whether my determinant of B itself is not equal to 0. If your determinant of B is equal to 0, in that case inverse does not exist. Correct? So first we'll find the cofactor matrix. So 2 minus 9 and here we'll get a minus 6. Right, here with a negative sign. So we are getting 8 plus 6, 8 minus 8, 0, 0, 0, 0 we are getting 8 minus 8. So we'll get 0 over here, minus 2 and minus 1 over here. Okay, and then third row, only change the sign over here. So you can solve like this. Okay, so we are getting minus 1, 3 and 2 over here. So transpose of this will be equal to your 2 minus 9 minus 6, 0 minus 2 minus 1 and minus 1, 3 and 2. This will be your adjoint of B. This will be your adjoint of B. 2, 0 minus 1, minus 9 minus 2, 3 minus 6 minus 1 and minus 2. Oh, wait, 2 only, right? 2, yes, it will be 2. Right, now determinant of A, determinant of B, sorry, determinant of B will be 1 into 8, 4, 1 multiplied with 4 into 2 minus 3 into minus 2, so minus 6, minus times, for second one minus, minus 1 multiplied with 0 minus 9, 0 plus 9, so like this, plus 2 multiplied with 0 minus 6, so minus 6. So what are we getting? 2 plus 9 plus, sorry, minus 12, minus 1. Just check whether we are getting minus 1 or not. Minus 1 we are getting, right? I think minus 1 only we are getting. So your B inverse will become this multiplied with minus 1 multiplied with this matrix, 0, 0, minus 1, minus 9, minus 2, 3, minus 6, minus 1, 2. So just multiply this minus inside, so it will be minus 2, 0, 1, 9, 2, minus 3, 6, 1, minus 2. This will be your B inverse. And try also check once on your own for your practice and your confidence, check B into B inverse will give you an identity matrix. You can check that. Okay, ji. Let's go ahead. A is invertible for, this type of question can also come for you. A is invertible for what value of K? So simply find the determinant. right? Simply find the determinant. Determinant should not be equal to 0. This is invertible. If you find the determinant like this, you will get 1 plus k square not equal to 0, and 1 plus k square is not equal to 0 for any k, right? This will always be positive. 1 plus k square will always be positive, so k belongs to R. For every real number, this will be a invertible matrix. A matrix will not be invertible only in the case when a square matrix will not be invertible only in the case when its determinant is equal to 0 or it's a singular matrix. JEE Advanced question from 2014. Let M be 2 cross 2 symmetric matrix with integer entries, then M is invertible if the first column of M is the transpose of the second column of M. 2 cross 2 matrix. A, B, C, D. Simple matrix only, we'll take the example now. First column of M is the transpose of second row of M. First column of M is the transpose of second row of M. That means C, D will come here and A, B will come here. Correct? That's what it means, right? No, first column of, wait, first column of M is transpose of second column of M would mean A and B are equal, B and C are equal. Right. First column of the matrix is transpose of second row of matrix. That can happen only in this case, na? A, B, B, C. Correct? This is your option number A. First column of M is transpose of second row of M. Right? In this case, what we will get? AC minus B square. So M is invertible if first column of M is transpose of second column of M, if matrix with integer entries are there, all the entries are integer. This is not going to be equal to 0. Is this going to be equal to 0? Is this going to be equal to 0? Tell me. Right? If your first column of M is the transpose of second column of M, all, right, this is the general case, right? Wait. This is the general case. In this case, what will happen? Think. Can it be a singular matrix? Can it be a singular matrix? Do you think? Right? It will be invertible. In this case, it will be invertible. It won't be 0. It's not necessary that AC minus B square will be equal to 0. So if this is the case, if first option is correct, that actually means all elements are same. All elements are same. And if all elements are same, determinant is definitely going to be equal to 0. Sir, why these many students are here? I don't know, beta. Maybe they are busy studying something else right now. Okay. I'm saying if first column of M is the think about it. Write and think on your own. If first column of M is the transpose of second row of M, first column of the matrix is transpose of second row of matrix. That means all elements are same. A, B, C, all are same. Right? If we are taking, because it is a symmetric matrix. First of all, it is a symmetric matrix. Right? We have to take the elements like this. It's a symmetric matrix. This is the diagonal. These two will be same. 2 cross 2 symmetric matrix. Okay. Now, first column of M is the transpose of second row of M. First column of M, that means AB, is the transpose of second row of M. That means this is equal to BC. That means this is equal to, that means A is equal to B and B is equal to C. All are equal. In that case, determinant of M will come out to be 0. That means it will not be invertible. Are you getting my point? Now, second row of M is the transpose of first column of M. What is our matrix? This is our matrix. Second row of M, that means B, C, is the transpose of first column of M. First column is this, that means this is equal to AB. Transpose of first column will be a row. So B equal to A and C equal to B, that means ABC. Again, all are equal. That means determinant of M will be equal to 0 because all elements are same, na? All elements same, that means determinant will come out to be equal to 0. M is the diagonal matrix with non-zero entries in the main diagonal. M is a diagonal matrix. That means M is a diagonal matrix. That means AC are there and this is 0, 0. That means AC. Non-zero entries, A and C both are non-zero. Then this will not be equal to 0. That means this option is correct. This will definitely be invertible. It is only non-invertible in the case. But I will support you. Thank you, Mahalakshmi. Thank you. That's good. That's so sweet of you. Okay. That means your matrix will be non-singular. Because A and C both are non-zero, rest everything is 0. So it will be correct. It will be invertible. Right? The product of entries in the main diagonal of M is not the square of an integer. That means AB minus B square. This thing. Now they are saying product of entries in the main diagonal. What are the entries in main diagonal? AC. Sorry, AC minus B square. These were the entries, no? This was our 2 cross 2 symmetric matrix. So AC minus B square. These were the entries. Product of entries in the main diagonal of M is not the square of an integer. This is square of an integer. AC is not the square of an integer. That means this will not be equal to 0. That means this is also true. It will be invertible. Right? Simple concept based questions can be asked in matrices in advance. So there is no load taking or there is nothing difficult or something out of the box only. You have to be conceptually very strong in the properties of matrix. That's it. Nothing else. Now, A inverse will again come out to be equal to A. This is by default. A transpose is also equal to A. So this will stick in your head. Determinant of A inverse will be equal to 1 by determinant of A. Determinant of A inverse will be equal to 1 by determinant of A. You can prove these also very easily. Right? Because what is your adjoint? What is your A inverse? A inverse is adjoint of A divided by determinant of A. Determinant if you take both the sides. Right? What will come here? Determinant of A to the power n minus 1. N minus 1 minus 1. N minus 1 plus 1. That means 0. That means again what will you get? You will get 1 by determinant of A. Correct? Adjoint of A. Determinant of adjoint of A is what? Determinant of A to the power n minus 1. Where is the n is the order. Right? So again you'll get this thing only. Try solving these. Right? But remember them. Try doing these once on your own so that they get stuck in your head. But remember them for the exam. Determinant of A inverse will be 1 by determinant of A. Very, very important. Sometimes very applicable. Inverse of A transpose or transpose of A inverse. Same thing. Transpose will come inside and out. Here also reversible law is applied. AB inverse will be B inverse into A inverse. Reversible law is applied for transpose, adjoint and inverse. Right? Remember that. Now let's do some questions. A is a 3 cross 3 non-singular matrix such that A into A transpose is equal to A transpose into A and B is equal to A inverse into A transpose. Then B into B transpose will be equal to what? Come on, try this. Think of attempting this. But what are they asking? B transpose they are asking. They are asking simply B into B transpose. Just put this. Everything is given to you. B is given to you. Right? B is given to you. So what will be B? B will be A inverse into A transpose. And B transpose will be transpose of this. Same thing. So A inverse into A transpose. Right? Now A inverse into A transpose multiplied with transpose over these. So A transpose first of all, right, multiplied with A inverse transpose. Correct? This is what is going to happen. Correct? Now let's write them. A inverse into A transpose. A transpose that means A inverse transpose that means A transpose inverse. Okay. Now A transpose into A. What is this? A transpose into A is A into A transpose. A transpose multiplied with A can be written as A into A transpose. So you cannot change the order just like that. You cannot write reversing. That's not allowed in matrices. That's the mistake which we do. A inverse into A transpose into A transpose inverse. Now A transpose is also a matrix. Na? A inverse into A will be equal to I. Obviously, A inverse into A. A is a non-singular 3 cross 3 square matrix. So A inverse into A will be equal to I. A transpose into inverse of A transpose will be equal to I. Right? Again, that will be equal to I. By A transpose is a matrix. Matrix into inverse of that matrix, which is non-singular. So that will be equal to I. I into I, that means I square, that means I again. I will be your answer. I square is also I. Right? Answer is your B option. Very good, Malakshmi. That was correct. Let's do some more. Now, linear equations. By inverse, you have to practice. Properties, write them down. Practice a few questions from your books. NCERT questions also you'll practice. No, that is also enough. But practice. If you don't, that's a problem. If you don't practice, that's a problem. Also, we'll have a practice session on Wednesday or Thursday. There also you can come on the platform for free and practice along with me. I'll make you practice some more matrices and determinants. System of linear equation is very important in matrices. Actually, system of linear equations we'll study in determinants. Right? In determinants we are going to study this. But I just want you to know that in terms of matrix also, what do we mean by system of linear equation? For example, these are the two equations, 2x plus 5y equals 1 and you have 3x plus 2y equals 7. Right? So there are two matrices. You just have to follow this. Capital A multiplied with capital X equal to B. Okay. Capital A is matrice of matrix of coefficients. Right? Capital X is your matrix of variables. And capital B is your matrix of constants. Simple thing. For example, over here, matrix of coefficients will be 2, 5, 3, 2. This is your A. Multiplied with X. That means column of variable X and Y. If we had 3, then it will be a 3 into 1 matrix, column matrix. Right? Equal to 1 and 7. Only this A will be a square matrix, rest B and X both will be column matrix always. Now you can see this is true, right? Because if you multiply this with this is 2 cross 2, this is 2 cross 1, right? So final matrix you will get as 2 cross 1. This is 2 cross 2, this is 2 cross 1. Final matrix you will get as 2 cross 1. That means 2 into X plus 5 into Y, right? And 3 into X plus 2 into Y will be equal to 1 and 7. Again we are getting the same thing. 2x plus 5y equal to 1, 3x plus 2y equal to 7. Sir, but what was new in this? How did it help me to solve? It's nowhere helping me to solve my question. How is this helpful? So this, in determinants we'll realize more efficiently that how it is helpful. But here what I can tell you, when I'm writing Ax is equal to B, right? X, if I multiply, if over here only, if I multiply with, if I divide, I can also write it like this. X is equal to A inverse of into B. Directly I can find X as A inverse B. This is how it is helpful. X is minus 3 and Y is, that is correct. This actually helps. Ax equal to B also means that X is A inverse into B. Right? What I've done, what did I do? I didn't divide or anything. I just multiplied inverse both the sides. A inverse both the sides. So A inverse A becomes I into X became X, and this is equal to A inverse B. This is what I am going to use. Direct solving. So for example, if my A I know, I know my A. What will be A inverse? Will I be able to find A inverse very easily? A inverse will be adjoint of A divided by determinant of A. Adjoint of A I can easily find. Adjoint of A will be nothing but in this matrix. So 2 minus 5 minus 3 and 2. This will be my adjoint of A. Determinant of A, I can find 4 minus 15. That means minus 11. This will be minus 11. So my X will be A inverse. What will be A inverse? That will be minus 11. Sorry, 1 by minus 11 multiplied with 2 minus 5 minus 3 and 2. This multiplied with B. X will be minus 1 by 11 multiplied with 2, 5, minus 5, minus 3 and 2 multiplied with B. What is my B? B is my column matrix, which is simply this. This is 1 and 7. So this way I'll be able to directly find. I'll directly get the value of X and Y. What is X? X is XY. This matrix is your X. Right? This is your X matrix. So 2 into 1 minus 5 into 7. 2 minus 35 minus 33. So minus 1 by 11. 2 into 1 minus 5 into 37. So 2 minus 35 minus 33 divided by minus 3, here minus 3 and plus 14. So minus 11. So you get X and Y value directly we are getting. Minus 1 by 11 multiplied over here. So it will be 3 and 1. X equals 3, Y equals 1. Y equals minus 1, minus 1, minus 1, minus 1. Minus 1 we are getting, na? Wait. Minus 3 plus 14, so plus 11 is here. Here we have plus 11. Here we have plus 11. Here we have minus 1. Yes, Y equals minus 1. So 6 minus 1, yes. And 9 minus 2, 7. Yeah. X equals 3 and Y equals minus 1. Directly we'll be getting plus 3 and minus 1. Yes. Malakshmi, that's correct. Y is minus 1, not 1. Y will be minus 1. So this is how. That's what. Matrices. This is how linear equations will help us, because directly X matrix will be equal to A inverse into B. If you can find A inverse and multiply it with B, you'll be easily able to find. Otherwise, I think solving two equations with two variables. But if it is a 3 cross 3 or if 3 variables are involved, no, in that case, yes, it will take time. So this is your equation. In this, A is this, X is this, B is this. A is your A1, A2, B1, B2, B3, A1, A2, A3, C1, C2, C3, that matrix. X is your variable column matrix and B is your constant column matrix. Okay, and directly you'll use X, that means this matrix will be equal to A inverse of this multiplied with this divided by determinant of this. Directly you'll be able to find the solution. Very rarely, so for example, this question, if you need to solve, so 1, 2, 3, 1, 1, 1 and 2, 2, 0 and minus 3, 1, 3 and 0. This is your A. X is XYZ column matrix. B is your 7, 11 and 1, your column matrix of the constants. So directly, what all you need to find? You'll first need to find A inverse. First find the A inverse and find determinant of A. Directly you'll A inverse, when you'll find, you'll get this. X will be equal to A inverse into B, that means this multiplied with this. Finally you'll get the values of X, Y and Z. This is the application of linear equations in matrices. Only in NCERT or in boards you might get a question to solve by using system of linear equations in matrices. Otherwise, obviously in JEE you'll not need to solve using this way. You will not need to solve using this way for sure. I can be sure of that. Right? Now, if here one more important thing is there. If your determinant of A is not equal to 0, then definitely you are going to have a unique solution. If while solving you have A, right? There is a matrix A. If determinant of that matrix is not equal to 0, that means you are going to have a unique solution, right? And if it is equal to 0, either you'll have no solution or you'll have infinitely many solutions. In which case you'll have no solution? If adjoint of A multiplied with B is not equal to 0, that means you have no solution. If adjoint of A multiplied with B is equal to 0, in that case you'll have infinitely many solutions, right? Because this just means that not all cofactors are 0. Right? If your adjoint of A cross B, adjoint of A multiplied with B is not equal to 0, that means you are having no solution. There is no possibility if this is not equal to 0. But if this is equal to 0, that means not all cofactors are coming out to be equal to 0. Note this down. This can be useful in boards definitely. So if you find the determinant of A and that does not come out to be equal to 0, that means you are going to have a unique solution. If it comes out to be equal to 0, then there are two cases. If adjoint of A multiplied with B is not equal to 0, in that case no solution. If adjoint of A multiplied with B is equal to 0, in that case infinitely many solutions. Okay, let's move ahead. Now, one thing which is called Cayley-Hamilton theorem. Now, when to use this? High powers of matrix can be used, write it down, can be used when we get an equation in matrix where higher powers are involved. Right? If you get an equation in matrix where higher powers of matrix are involved, suppose A is a matrix and they are giving you an equation A cube minus 2x square plus A minus I, find the value of this, right? With normal method you will take a lot of time, but Cayley-Hamilton theorem is taught for those specific questions where inside matrix equation, some equation, let's say there is A is a matrix and A cube minus 2A square plus 3A minus I, value of this is asked, right? In this case, if you have matrix A and you keep finding all these terms, A cube, A square, A, and keep doing that, this might take a lot of time. And some more things can be asked which can only be solved by using the Cayley-Hamilton theorem. Right? So what does this theorem say? This theorem says that there is an equation which will be satisfied. Suppose if A is your square matrix, if A is a square matrix, then always A minus xi, mod of A minus xi will be equal to 0. This will be the equation satisfied by matrix. This is your Cayley-Hamilton equation. This is your, or you can say characteristic equation, right? We'll call it as characteristic equation. I think it's written, right? It's written. This is your characteristic equation. A minus xi is your characteristic equation. For example, let's say my A is 2, 3, 1, 4, right? So A, that means 2, 3, 1, 4 minus xi of same order, I of same order, x into identity matrix of same order will become x0, 0, x multiplied with I of same order, right? This will be equal to 0. This will be the characteristic equation of matrix A. That means 2 minus x, right? 2 minus x, and here we'll have 3, here we'll have 1, here we'll have 4 minus x. Determinant of this will be equal to 0, and this is your characteristic equation. This is your characteristic equation. Determinant of this putting equal to 0. When you do A minus xy, determinant of this equal to 0, this is called the characteristic equation of that matrix. For example, characteristic equation of this particular matrix, if we need to find, so 2, 3, 1, 0, this is your A minus x times I of same order, that means x, 0, 0, x. Determinant of this, that means determinant of 2 minus x, 3, 1, and minus x. That means this will be equal to 2 minus x into minus x minus 3 will be equal to 0. So what will be the characteristic equation? It will become x square minus 2x minus 3 equals 0. This will be the characteristic equation of matrix A, which is this matrix. Characteristic equation of this matrix will be x square minus 2x minus 3. Okay. All right. So, x square minus 2x minus 3. Now, so characteristic equation of this is x square minus 2x minus 3. This is how you write the characteristic equation. Now, what to do with the characteristic equation? Cayley-Hamilton theorem says that every matrix will satisfy its own characteristic equation, and obviously A minus xi is equal to 0. By every matrix will satisfy its own characteristic equation. It simply means A minus, instead of x, if I put A, so this should be equal to 0, which is true. AI will again be equal to A, and this will be equal to 0. Yes, this is but obvious that every matrix will satisfy its own characteristic equation. That's it. This is what we use to find many things in questions. For example, so x square minus 2x minus 3 will be satisfied by a square minus 2a minus 3i. 3 directly we cannot write. We are adding and subtracting a matrix, so I will have to write. Right? So a square minus 2a minus 3i will be equal to 0. This will be true for matrix A. Every matrix will satisfy its characteristic equation. Now let's talk about this. For example, this question. Right? This is also a PYQ. A inverse is this given to me. Find C and D. A inverse is equal to something, and I have to find C and D, for example, let's say. Right. Now, first, let's see if I can find the characteristic equation of this particular matrix. Let's first see that whether I'll be able to find the characteristic equation. Try to write the characteristic equation of this particular matrix. Try to write the characteristic equation of this particular matrix. Right? Try writing. So simple, step by step I'm going to tell you. 1 0 0 0 1 1 0 minus 2 4. This is your A minus xi. That means identity matrix multiplied with x of order 3. So x 0 0 0 x 0 0 0 x. That's it. Determinant of this you need to find. Right? So this will become determinant of 1 minus x 0 0 0 1 minus x 0 1 over here 1, right, and 0 minus 2 and 4 minus x. This will be equal to 0. Now this you have to open and let's see what it comes out to be. X cube minus 6x square plus 11x minus 6. This will come out to be x cube minus 6x square plus 11x minus 6 equal to 0. This is going to be the characteristic equation. When you open this matrix, this is what you are going to get. And every matrix satisfies its characteristic equation. That means a cube minus 6a square plus 11a minus 6 will be equal to 0. This will also be true. This will also be true for sure. But how does this help us? Can we reduce it to a square or something like that? Can we reduce it to a square or something related to that? Yes, obviously. Multiply this with a inverse. Multiply a inverse on both the sides. This is a PYQ. That's why it is tricky. Otherwise, I'm directly making you practice with a PYQ. Normal questions you'll be able to practice if you have understood this. Multiply a inverse. So what will you get? A inverse into a cube minus 6 into a inverse into a square plus 11a into a inverse minus 6a inverse equal to 0. Correct? So A inverse into A will become I. I into A square will remain over here. One A I'll take out, A square into A will become I into A square will again be A square. So this will be A square minus A inverse into minus 6 times A plus 11. Plus 11 is equal to 6 times A inverse. Correct? Now you must have understood, right, what I'm trying to say. I'm just going to bring this 6 down. So I'll have A square minus 6A plus 11 equal to A inverse. And this is exactly what's written over here. So C will become equal to minus 6, D will become equal to 11. Right? 11 or 11 I should write. So D will become equal to 11. What do you need to do? Find C and D. C will be equal to minus 6 and D will be equal to 11. Right? This is how Cayley-Hamilton theorem will help you in some of the really good and specific questions. Now some observations about Cayley-Hamilton theorem. For example, if we talk about this particular characteristic equation, or if we talk about, did we have 2 cross 2? Didn't we have 2 cross 2? This one. This characteristic equation was x square minus 2 times x minus 3. Now always remember, sum of roots of any characteristic equation, sum of roots of any characteristic equation will be equal to trace of A, and product of roots of any. Now basically it is saying that for a 2 cross 2 matrix, characteristic equation can be written like this. You don't need to remember this. Simple, this you can remember. For a matrix 2 cross 2, it will just be x square minus trace of A into x plus determinant of A. Right? X square minus trace of A into x. For example, we talk over here. Right? X square minus, what is trace of A? Trace of A means sum of elements in diagonal. Trace means sum of elements in diagonal. 2 plus 0. So 2. X square minus trace of A into x. That means x square minus sum of elements in the diagonal into x. Trace means trace of A is sum of elements in diagonal. Right? So sum of elements in diagonal is 2. X square minus trace of A into x plus determinant of A. What is determinant of A? 2 minus 3, that means minus 3. So plus minus 3, that means minus 3. X square minus 2x minus 3. Now you see, sum of roots will always be equal to trace. Trace divided by coefficient of x square. Sum of roots will be this minus 2. Sum of roots, you can see, is equal to minus 2. Minus of b by a, that's what we say. And product of roots will be equal to determinant. Product of roots, you can say product of roots of this equation is equal to minus 3. That means it will be equal to determinant of this particular matrix. That's what it is saying. And yes, these 2 points do help us in solving really good questions of JEE Advanced. Listen and understand very carefully. Characteristic equation of a 2 cross 2 matrix will look like this. Some ax square minus bx plus bx plus c equal to 0. It will be a 2-degree equation, right? And sum of roots, that means alpha plus beta. Suppose it has alpha and beta as the roots. We know alpha plus beta will be equal to minus b by a. This b will always be trace of matrix A. This b, this small b will always be equal to trace of matrix A. Okay, so your sum of roots will always be equal to trace of matrix A divided by coefficient of x square if there is. Right? Or we can say this minus b by a will always be equal to trace of A. Trace of A means sum of elements in the diagonal of matrix A. This minus b by a will always be equal to that, because you can divide by a everywhere. And c by a will be equal to determinant of matrix A. It will always be true. In case of 3 cross 3, it is a bit complex, but main thing you should remember, in this case also, alpha plus beta plus gamma, that means will be equal to minus b by a, will be equal to the trace of matrix A. And alpha beta gamma, that is minus, in this case it will be b c d, d by a, minus plus minus, also minus d by a, that will be equal to your determinant of A. That's it. Remember these 2 points. Right? Can be used in case of advanced questions sometimes. For example, we have A is this, alpha, beta are this, such that alpha A square plus beta A minus 2i is equal to 0. Alpha A square plus beta A minus 2i is equal to 0. Abhi, this is A and this is your characteristic equation. Obviously, what will be the characteristic equation? Alpha x square plus beta x minus 2 will be equal to 0. This will be your characteristic equation. Right? This should be your characteristic equation. Right? Now, what will be your alpha? What will be the sum of roots? What will be the sum of the roots? The two values that we get. That will be equal to trace of A. Correct? Am I wrong or right? Right? Sorry. Acha, we can compare directly also. That thing also we can do. That's what you are writing. Yeah. We can compare. Definitely we can compare directly without any trouble. That thing is obviously always by default. Right? But here, if here alpha beta they are asking coefficient, so we'll have to make the characteristic equation and then compare. We can make the characteristic equation, right? Try making, come on. Come on, try making. If you can directly make the quadratic equation, you'll like characteristic equation, you'll directly get the value of alpha and beta. Now here there is no role of sum of roots and product of roots actually. We'll make the characteristic equation. It will become 1 minus x, 2 minus 2 and minus 5 minus x, determinant of this. Correct? Directly I can write determinant of this. That means 1 minus x into minus x minus 5 minus plus 4 equal to plus 4 equal to 0. So this will become x minus 5 and x minus 1. So this we can write as minus common from here. So this will become x minus 1 and this will become x plus 5. So x square minus x plus 5x plus 4x minus 5 plus 4 equals 0. So it will be x square plus 4x minus 1 equal to 0. Will be satisfied by own matrix. So that will be a square plus 4a minus I equal to 0. This is what we are getting, no? But there is a 2i over here. There is a 2i. So we'll have to multiply with 2. So this will become 2a square plus 8a minus 2i equal to 0. Correct? There is a 2i over there. So this will become, yeah, right? This will become, so your alpha will become 2, beta will become 8 and your alpha plus beta will be equal to 2 plus 8. That means equal to 10. Right? So here we didn't get to use alpha plus beta equal to something, but suppose if they asked something related to coefficients, then just remember, then sum of roots of your characteristic equation will be equal to trace of the matrix and product of roots of your characteristic equation will be equal to determinant of the matrix. Very important this is. I don't think I have question related to this, but yeah, this is actually very important. Sometimes in advance you'll get question in practice session. Practice session link will be given in the same video. The practice session link will be in the same video where I'll bring some questions where you'll see how Cayley-Hamilton theorem is going to be used. Apart from that also I'll bring some more questions related to our matrices and determinants. After completing the determinants, we'll do this practice session. So I think tomorrow morning or tomorrow evening, by tomorrow evening, we'll complete determinants also. Now I'm taking a pause because it's been 3.5 hours and I don't want to speak continuously too much. Determinants will take in the upcoming session tomorrow or day after, tomorrow evening or day after tomorrow max. But yeah, after taking matrices and determinants both combinedly, we'll do a practice session on matrices and determinants specifically for second attempt of our JEE Mains. All right. So all the best. Take care. Have fun. Determinants in next session. Determinants is smaller than matrix, right? In most of the determinant part, most of the things which are going to be used with matrix is already covered. Some properties of determinants and some tricks related to determinants I'll tell you in the separate session, which I'll take tomorrow evening or day after tomorrow morning max. So bye bye, take care, have fun, keep learning, keep having fun. Thanks a lot.